Picture yourself waking up to the harsh sound of an alarm clock. Before your eyes are fully open, you reach for your phone, the screen's blue light flooding your retinas. You scroll through notifications, messages, news alerts, each one tugging at your attention. You rush through a quick breakfast, maybe grabbing a packaged granola bar or a sweetened coffee drink, before sitting down at a desk where you'll spend the next 8 hours staring at a screen, your body barely moving except for your fingers dancing across a keyboard. At lunch, you eat quickly, often while still working, barely tasting the processed food you've heated in a microwave. The afternoon drags on under artificial lights, and when evening finally arrives, you're exhausted despite having barely moved your body. You collapse onto your couch, scrolling through social media, comparing your life to the curated highlights of hundreds of people you barely know, feeling simultaneously connected and profoundly alone. You stay up too late, the glow of your devices keeping your brain alert long after darkness has fallen, and when you finally sleep, it's fitful and insufficient. This scenario is familiar to millions of people across the modern world. It feels normal because it's what we know, what we've grown accustomed to, what our society expects. Yet every element of this daily routine represents a fundamental departure from the conditions in which human beings evolved. Our bodies, our brains, our deepest biological programming were shaped over hundreds of thousands of years in environments radically different from the one most of us inhabit today. And this disconnect, this mismatch between our evolutionary heritage and our modern reality, lies at the heart of many of the physical and psychological struggles that plague contemporary life. The concept of evolutionary mismatch is both elegant and unsettling. At its core, it describes what happens when an organism finds itself in an environment that differs significantly from the one in which it evolved. The traits that once helped that organism survive and thrive become maladaptive, even harmful, in the new context. Think of a palm tree transplanted from the tropics to a snowy climate. The very characteristics that made it flourish in warm, sunny conditions, like its broad leaves designed to capture maximum sunlight, become liabilities when frost arrives. The tree wasn't designed for snow. It can't adapt quickly enough. And without intervention, it will die. Human beings face a similar challenge, though our situation is far more complex and nuanced. We are not dying from our modern environment in the immediate, dramatic way a tropical plant dies in winter. Instead, we're experiencing a slower, more insidious form of suffering. We're seeing unprecedented rates of obesity, diabetes, cardiovascular disease, depression, anxiety, insomnia, and a host of other conditions that were remarkably rare among our ancestors. We're watching as chronic diseases have become the leading cause of death worldwide, replacing the infectious diseases and immediate dangers that threatened our forebears. And increasingly, scientists are recognizing that many of these modern afflictions stem not from defects in our biology, but from a profound mismatch between our ancient bodies and our contemporary world. This isn't about romanticizing the past or suggesting we should return to living in caves. Our ancestors faced tremendous hardships, including high infant mortality, shorter lifespans, vulnerability to predators, and the constant threat of starvation. Modern life has brought us extraordinary benefits: medical advances, technological marvels, unprecedented access to information, and comforts our ancestors couldn't have imagined. But these benefits have come with hidden costs, and understanding evolutionary mismatch helps us see what those costs are and, crucially, what we might do about them. The human story is one of remarkable adaptability. Our species, Homo sapiens, emerged roughly 200,000 years ago in Africa. For the vast majority of that time, spanning approximately 95% of our existence, we lived as hunter-gatherers. We moved in small bands of perhaps 30 to 150 individuals, people we knew intimately. We spent our days walking, sometimes running, across varied terrain, searching for food, gathering plants, hunting animals. We lived in close contact with nature, Sleeping under the stars or in simple shelters, waking with the sun, our days structured by the rhythms of light and darkness, the seasons, the movements of game. Our diets were diverse, consisting of whatever we could find: wild plants, fruits, nuts, seeds, occasionally meat from animals we tracked and killed. Food was sometimes scarce, requiring considerable effort to obtain, and we evolved mechanisms to store energy as fat during times of plenty to survive times of scarcity. Our social structures were egalitarian and based on direct face-to-face relationships. We knew everyone in our group. We cooperated closely in tasks, shared resources, raised children communally. Our brains developed complex social abilities to navigate these relationships, to read facial expressions, to understand social hierarchies, to form bonds. We were deeply embedded in our physical environment, our survival depending on intimate knowledge of local plants, animals, weather patterns, and terrain. Physical danger was real and immediate. Predators and rival groups posed genuine threats, and our stress response systems evolved to help us react quickly to such dangers. This way of life, this environment, shaped us at the deepest biological level. Our genes, our hormones, our neurotransmitters, our skeletal structure, our digestive system, our immune function, our sleep patterns, our psychological tendencies, all evolved under these conditions. Natural selection favored traits that helped humans survive and reproduce in this ancestral environment. And here's the crucial point. Evolution works slowly. It takes thousands of generations for significant genetic changes to occur in response to new environmental pressures. The human genome hasn't changed much in the past 10,000 years, and it certainly hasn't changed appreciably in the past 200 years since industrialization began, or the past 30 years since the digital revolution commenced. But our environment has changed dramatically and rapidly. About 10,000 years ago, some human groups began to transition from hunting and gathering to agriculture. This Neolithic revolution transformed human life. People settled in one place, cultivating crops and domesticating animals. Populations grew. Diets became less diverse, often dominated by a few staple grains. Social structures became more complex and hierarchical. Infectious diseases spread more easily in denser populations. Yet this transition, as significant as it was, still allowed for considerable physical activity. Farming is hard work. People still moved their bodies extensively, still spent their days outdoors, still lived relatively close to natural rhythms. The real rupture came with industrialization, beginning around 200 years ago. Suddenly, in evolutionary terms almost instantaneously, human life changed in ways that would have been unrecognizable to our ancestors. We moved from farms to factories, from rural areas to cities. We began working long hours in indoor environments, performing repetitive tasks. We gained access to processed foods, refined sugars, and eventually, ultra-processed products designed to be hyper-palatable. We developed artificial lighting, allowing us to extend our waking hours well past sunset. We created transportation systems that dramatically reduced the need to walk or move. And most recently, in just the last few decades, we've experienced the digital revolution, bringing screens into nearly every aspect of our lives, connecting us to vast networks of people we'll never meet, flooding us with information and stimulation 24 hours a day. Our genes haven't caught up. They can't. Evolution operates on a timescale of thousands of generations, not decades or centuries. We are, in essence, running ancient biological software on modern hardware, or perhaps more accurately, we're trying to run ancient hardware in a completely novel environment. And the glitches, the bugs, the system crashes, these manifest as the chronic diseases and psychological struggles that characterize modern life. Understanding evolutionary mismatch doesn't mean we can or should try to recreate ancestral conditions. That's neither possible nor desirable. But it does offer us a lens through which to view our current challenges. And more importantly, it suggests concrete, practical ways, we might align our modern lives more closely with our evolutionary heritage, reclaiming aspects of health and well-being that we've inadvertently lost in our rapid race toward progress. In the sections that follow, we'll explore the many dimensions of evolutionary mismatch, examining how our ancient bodies struggle in modern contexts. We'll look at diet, physical activity, sleep, social connections, mental health, work, and our relationship with nature. We'll see how each area reveals a gap between what we're biologically prepared for and what our contemporary world demands or offers. And we'll consider what we might do about it, both as individuals and as a society, to bridge these gaps and live in ways that honor both our evolutionary past and our modern aspirations. The foundations. How evolution shaped us. To truly grasp the concept of evolutionary mismatch, we need to understand the environment that shaped us. We need to journey back in time to see the world through the eyes of our ancestors, to feel the contours of the life for which our bodies and minds were designed. This isn't an exercise in nostalgia or primitivism. It's an attempt to understand the baseline, the reference point against which we can measure the changes that have occurred in such a brief span of evolutionary time. Human evolution is a story millions of years in the making, but for our purposes, we'll focus on the period most relevant to understanding modern mismatch, the time span during which anatomically modern humans, Homo sapiens, existed. Our species emerged approximately 300,000 years ago in Africa. For the vast majority of that time, until roughly 10 to 12,000 years ago, humans lived as hunter-gatherers. Some isolated populations continued this lifestyle much longer, and a handful of groups still practice forms of hunting and gathering today, though increasingly influenced by contact with agricultural and industrial societies. The hunter-gatherer lifestyle was not monolithic. Different groups adapted to different environments, from tropical forests to Arctic tundra, from coastal regions to inland savannas. But despite this diversity, certain broad patterns characterized human life for most of our evolutionary history. These patterns shaped us, molding our bodies and minds through the slow but powerful force of natural selection. Consider daily physical activity. Our ancestors didn't exercise in the modern sense. They didn't have gyms or workout routines. But movement was inseparable from survival. Studies of contemporary hunter-gatherers, like the Hadza of Tanzania or the San people of southern Africa, suggest that ancestral humans walked between 5 and 9 miles per day on average. This wasn't leisurely strolling. It involved varied terrain, climbing, carrying loads, sometimes running. Hunting required intense bursts of activity, tracking animals over long distances, the careful stalking and chase. Gathering meant bending, squatching, reaching, digging, building shelters, making tools, preparing food, all involved manual labor. From childhood through old age, human bodies were in near constant motion. Our skeletal structure evolved to support this level of activity. Our muscle fibers, our cardiovascular system, our metabolism, all developed in the context of daily physical exertion. Now consider diet. The human digestive system is remarkably adaptable, which allowed our ancestors to survive in diverse environments. But certain principles held across most hunter-gatherer societies. Food had to be obtained through effort. There was no refrigeration, no long-term storage for most items. People ate what they could find or kill, and that varied by season and location. Diets were diverse, often including dozens or even hundreds of different plant species over the course of a year, along with occasional meat, fish, eggs, insects. Crucially, almost everything our ancestors ate was a whole food, meaning it contained not just macronutrients like proteins, fats, and carbohydrates, but also a vast array of micronutrients, fiber, and other compounds. There were no refined sugars, no processed oils, no additives or preservatives. Foods were relatively low in calorie density compared to modern processed options. meaning you had to eat a larger volume to get the same number of calories. The availability of food was unpredictable. Sometimes resources were abundant, and people could eat well. Other times, food was scarce, and people went hungry. This uncertainty shaped our metabolism in profound ways. Natural selection favored individuals who could efficiently store energy when food was available, and who craved high-calorie foods like fats and sugars, which were rare but valuable. The ability to put on fat during times of plenty increased chances of survival during times of scarcity. Similarly, mechanisms that slowed metabolism during periods of fasting helped conserve energy. These adaptations, now often called the thrifty gene hypothesis, made perfect sense in an environment where the next meal was never guaranteed. Sleep patterns in ancestral environments followed natural cycles. Without artificial light, human activity was largely constrained to daylight hours. Research on contemporary pre-industrial populations shows that people typically didn't go to sleep immediately at sunset, often staying up for a few hours around campfires, socializing and storytelling, but they also didn't stay awake deep into the night. Sleep duration averaged between 6.5 to 7.5 hours, not dramatically different from modern recommendations, though the quality and structure of that sleep may have differed. Interestingly, historical records from pre-industrial Europe suggest that people often slept in two distinct phases, a first sleep and a second sleep, with a period of wakefulness in between. This biphasic sleep pattern appears to have been common. The light environment itself was fundamentally different. Days were spent outdoors, exposed to full-spectrum sunlight, which is many times brighter than typical indoor lighting. This bright daytime light helped entrain circadian rhythms, the internal biological clock that regulates sleep, hormone production, and numerous other physiological processes. Evenings were illuminated only by fires, which produce a warm, reddish light that's far less disruptive to melatonin production than the blue-rich light from modern devices. Nights were dark, truly dark, in a way that's increasingly rare in our artificially lit world. Social life was intimate and immediate. Hunter-gatherer bands typically consisted of 25 to 150 individuals, with an average around 30 to 50. These were people you knew deeply, people you saw every day, people with whom you shared food, shelter, danger, celebration. Social bonds were formed through constant face-to-face interaction, through collaborative work, through shared experiences. The British anthropologist Robin Dunbar has argued that humans have a cognitive limit to the number of stable social relationships we can maintain, approximately 150, a figure now known as Dunbar's number. This limit, Dunbar suggests, evolved in the context of small group living and relates to the size of the neocortex relative to the rest of the brain. Relationships within these groups were largely egalitarian, at least compared to later agricultural and industrial societies. While there were certainly status differences and respected individuals, there were no massive hierarchies, no distant rulers, no corporate bosses. Leadership was often situational and fluid. Decisions were made collectively. Resources were shared. Children were raised not just by parents, but by extended family and the broader community. This social structure meant that people had defined roles within their groups, a sense of belonging, and direct feedback on their contributions. The natural environment was ever present. People lived immersed in nature, not separate from it. They knew the plants around them intimately, which were edible, which had medicinal properties, which were poisonous. They understood animal behavior, tracking patterns, seasonal movements. They read weather signs, predicted rain or drought. Their survival depended on this knowledge. And beyond utility, the natural world provided aesthetic and emotional experiences. The textures, sounds, smells, sights of wilderness surrounded them constantly. Stress in this environment was typically acute rather than chronic. When danger appeared, a predator, a rival group, a sudden storm, the stress response activated. The sympathetic nervous system flooded the body with adrenaline and cortisol. Heart rate increased, blood pressure rose, muscles tensed, preparing the body for fight or flight. This response was adaptive. It helped ancestors survive immediate threats. But crucially, once the danger passed, the stress response deactivated. The parasympathetic nervous system took over, bringing the body back to baseline. Stress was intense but time-limited. This, then, was the environment of evolutionary adaptedness, the context in which human biology was shaped. It's important to acknowledge what this picture leaves out. Ancestral life was not idyllic. Infant and child mortality was high. Many people died young from injuries, infections, childbirth complications. Violence was a real risk. Starvation was a periodic threat. Life was often difficult, uncertain, and harsh. The point isn't that the past was better than the present in any absolute sense. Modern advances in medicine, technology, and human rights have improved life in countless ways. But neither was ancestral life uniformly brutal and miserable. Evidence suggests that hunter-gatherers, when resources were adequate, often had considerable leisure time, perhaps working only 3 to 5 hours a day on subsistence activities. They had strong social bonds, a sense of purpose, connection to their environment, and most, relevant for our discussion, they were living in alignment with their biology. Their diet matched their digestive system, their activity levels matched their musculoskeletal needs, their sleep patterns matched their circadian biology, their social structures matched their psychological needs. Then came agriculture. The Neolithic Revolution, beginning around 10,000 to 12,000 years ago in the Fertile Crescent, and developing independently in other regions, fundamentally altered human society. People domesticated plants and animals, settled in permanent villages, eventually building cities. This shift brought enormous changes. Food production became more reliable, supporting larger populations. Social structures became more complex and hierarchical. Specialized occupations emerged. Technology advanced. Civilizations rose. But agriculture also introduced new stresses and health challenges. Diets became less diverse, often relying heavily on a few staple crops like wheat, rice, or corn. These grains required extensive processing and provided less nutritional variety than the diverse diet of hunter-gatherers. Skeletal evidence shows that early farmers were often shorter and less robust than their hunter-gatherer predecessors, suggesting nutritional deficiencies. Living in denser populations facilitated the spread of infectious diseases. Class systems created inequality. Life, in many ways, became more physically demanding in some respects. The labor of farming was intense, but also more sedentary in others, with people confined to specific plots of land. Still, the transition to agriculture occurred over thousands of years. There was time for some genetic adaptations. Lactase persistence, the ability to digest milk into adulthood, evolved in populations that herded dairy animals. Other adaptations related to starch digestion and disease resistance emerged. And crucially, agricultural life still involved considerable physical labor, direct exposure to natural cycles, and face-to-face community bonds. The real acceleration came with industrialization. Beginning in the late 18th century, starting in Britain and spreading globally, human societies underwent a transformation of unprecedented speed and scope. People moved from farms to cities, from varied outdoor work to repetitive indoor factory labor. Mechanization reduced the need for physical exertion. Fossil fuels powered new technologies. Later, electricity brought artificial light, refrigeration, and eventually the entire suite of modern appliances. The 20th century saw the rise of automobiles, processed foods, television, computers, and finally, the internet and smartphones. Each of these innovations brought genuine benefits. Electricity illuminated homes and extended productive hours. Cars provided mobility and freedom. Processed foods offered convenience and solved problems of food preservation. Digital technologies connected people across vast distances and provided access to unprecedented information. But these same innovations also created new mismatches. Artificial light disrupted sleep. Cars reduced physical activity. Processed foods provided empty calories. Digital devices hijacked attention and distorted social interaction, and the pace kept accelerating. Consider that the internet became widely accessible only in the mid-1990s, just 30 years ago. Smartphones, now ubiquitous, gained mass adoption only in the late 2000s. Social media platforms like Facebook, Instagram, and Twitter exploded in popularity in the 2010s. In the space of a single generation, the way people communicate, work, and spend leisure time has been revolutionized. This is the crux of evolutionary mismatch. Our genes, shaped over hundreds of thousands of years in one set of conditions, now operate in an environment that has changed almost unrecognizably in just a few thousand years, and most dramatically, in just the last 2 centuries. We are, in the words of evolutionary psychologists, Stone Age brains in modern skulls, or cavemen in the fast lane. Our biology hasn't caught up because it can't. Evolution requires time, generations, the slow sifting of natural selection. We don't have that time. The modern world isn't waiting. This realization can feel discouraging, even fatalistic. If we're fundamentally mismatched to our environment and we can't change our biology quickly, aren't we doomed to suffer? Not necessarily. Understanding mismatch is the first step toward addressing it. We can't go back, but we can go forward more thoughtfully. We can make choices, both individual and collective, that acknowledge our evolutionary heritage and work with our biology rather than against it. We can redesign aspects of our environment to better fit our needs. We can reclaim practices that honor our ancestral roots while still embracing the benefits of modernity. But to do that effectively, we need to understand the specific ways in which modern life mismatches our evolved biology. We need to examine the details, the mechanisms, the consequences. In the sections that follow, we'll do exactly that, exploring how the mismatch plays out across different domains of life, from what we eat to how we move, from how we sleep to how we connect with others. Each area tells part of a larger story about who we are, where we came from, and how we might navigate the strange, stimulating, often overwhelming world we've created for ourselves. The diet dilemma. Few aspects of modern life reveal the evolutionary mismatch as starkly as our relationship with food. Walk into any supermarket in the developed world, and you're confronted with aisles upon aisles of products that would be unrecognizable to anyone living just a century ago, let alone to our hunter-gatherer ancestors. Brightly colored packages promise convenience, flavor, and satisfaction. Shelves overflow with an abundance of calories that would have seemed miraculous to people who spent their lives worried about where their next meal would come from. Yet this very abundance, this triumph of food science and industrial agriculture, has become a primary driver of chronic disease, contributing to epidemics of obesity, type 2 diabetes, cardiovascular disease, and metabolic syndrome. The story of dietary mismatch begins with a simple principle. Our taste preferences evolved in an environment of scarcity. For most of human history, calories were hard to come by. Our ancestors had to work for their food, walking miles to forage for plants, tracking and hunting animals, all with no guarantee of success. In this context, natural selection favored individuals who sought out and enjoyed calorie-dense foods, particularly those containing fats and sugars. These nutrients provided concentrated energy and were relatively rare in the ancestral environment. Fruits were seasonal, honey was difficult to obtain, fatty meat was an occasional prize. When our ancestors encountered such foods, their brains rewarded them with pleasure, releasing dopamine and creating positive associations that motivated them to seek these foods again. This preference made perfect evolutionary sense. The person who loved the taste of honey and made the effort to climb trees and brave bee stings to get it had an advantage over someone who didn't. The person who craved the rich fat of marrow had extra energy stores to survive lean times. But there was a built-in limit. These foods were scarce. You couldn't eat unlimited honey because there wasn't unlimited honey available. your appetite for sweet, fatty foods was constrained by the environment itself. Now, fast forward to the modern world. Food scientists have decoded the neural circuitry of pleasure and reward. They understand that combinations of sugar, fat, and salt, in specific ratios and textures, trigger powerful responses in our brains. And armed with this knowledge, they've engineered products designed to be what researchers call hyperpalatable, triggering our evolved cravings far more intensely than any natural food. A candy bar delivers sugar and fat in concentrations no natural food could match. A bag of chips provides a crunch and a salt-fat-carbohydrate combination that hijacks our taste buds. A fast food burger and fries offer caloric density and flavor intensity that would have been unimaginable to our ancestors. These foods are also incredibly convenient and inexpensive, at least in terms of money. They require no preparation, no hunting, no gathering, no cooking. You can obtain them with minimal effort, often without even leaving your car. And they're available 24 hours a day, 7 days a week, in quantities limited only by how much you can afford and consume. The scarcity that once constrained our appetites has vanished. We live in a world of unprecedented caloric abundance, surrounded by foods engineered to be irresistible. Our bodies respond to this abundance by doing exactly what they were designed to do. They store the excess energy as fat. The mechanisms that evolved to help our ancestors survive periods of famine now work overtime, packing away calories against a future scarcity that never comes. The result is that more than 2/3 of adults in many developed nations are now overweight or obese. Childhood obesity has tripled in recent decades. And with obesity comes a cascade of health problems: type 2 diabetes, cardiovascular disease, hypertension, certain cancers, sleep apnea, joint problems, and more. This phenomenon is captured by what's known as the thrifty gene hypothesis, proposed by geneticist James Neal in 1962. The idea is that genes that promoted efficient fat storage and helped maintain blood sugar levels during periods of feast and famine were advantageous in ancestral environments. But these same genes become problematic in environments with constant food availability and high-calorie diets. The metabolic systems that once kept people alive now predispose them to disease. The evidence for this hypothesis comes from multiple sources. Population studies show that indigenous groups like the Pima Indians of Arizona experienced rapid increases in obesity and diabetes when transitioning from traditional diets to modern Western diets. Their genes, adapted to an environment of periodic scarcity, made them particularly vulnerable when exposed to caloric abundance. Similarly, research on hunter-gatherer populations living traditional lifestyles, like the Tsimane of Bolivia or the Hadza of Tanzania, shows remarkably low rates of obesity, diabetes, and cardiovascular disease, despite these groups often consuming diets relatively high in carbohydrates or fats, depending on their environment. The problem isn't just the quantity of calories, but also the quality and composition of modern foods. Our ancestors ate whole foods, foods that came more or less directly from plants or animals. An apple eaten by a Bursin hunter-gatherer was the same apple that grew on the tree, with all its fiber, vitamins, minerals, and phytonutrients intact. Meat was consumed in its natural state, often including organs and other nutrient-dense parts that are rarely eaten in modern Western diets. Contrast this with ultra-processed foods, which now make up more than half of the caloric intake in many developed countries. These are products that have been broken down, reconstituted, and loaded with additives, preservatives, emulsifiers, and flavor enhancers. They often have long shelf lives and bear little resemblance to anything found in nature. A chicken nugget is a far cry from a whole chicken. A fruit-flavored snack bears little relation to actual fruit. These products are stripped of fiber and many micronutrients during processing, then often fortified with a few vitamins to replace what was lost. But this fortification is a pale shadow of the complex nutritional matrix found in whole foods. Recent research has introduced the concept of dark matter nutrition, referring to the thousands of compounds in whole foods beyond the basic macronutrients and the handful of vitamins and minerals we focus on. Plants contain thousands of phytonutrients, many of which likely play important but poorly understood roles in human health. The human gut microbiome, the trillions of bacteria that live in our digestive system, has co-evolved with us and depends on certain compounds found in whole foods, particularly fiber and plant polysaccharides. The shift to processed foods has dramatically reduced the diversity of compounds we consume, potentially shrinking what researchers call our metabolome, the complete set of metabolic products in our bodies. This reduction in dietary diversity may have far-reaching consequences. Studies show that people consuming high amounts of ultra-processed foods have increased risks not just of obesity and metabolic disease, but also of depression, anxiety, and cognitive decline. The mechanisms are still being unraveled, but they likely involve inflammation, oxidative stress, microbiome disruption, and nutrient deficiencies that affect brain function. Another critical aspect of dietary mismatch involves our consumption of specific nutrients that were scarce in ancestral environments, but have become ubiquitous in modern diets. Sugar is perhaps the most obvious example. Our ancestors encountered natural sugars in fruits, honey, and some vegetables. But these sources were limited and came packaged with fiber, which slows absorption and limits how much you can consume at once. Modern diets, in contrast, are flooded with added sugars, particularly high fructose corn syrup, which appears in everything from soft drinks to bread. The average American now consumes over 70 pounds of added sugar per year, a quantity that would have been unthinkable in ancestral times. High sugar intake has multiple harmful effects. It causes rapid spikes in blood glucose and insulin, putting stress on the pancreas and eventually leading to insulin resistance, a hallmark of type 2 diabetes. Fructose, in particular, is metabolized primarily in the liver and, in high quantities, can lead to fat accumulation in that organ, contributing to non-alcoholic fatty liver disease. Excess sugar intake also raises uric acid levels, which are linked to gout, hypertension, and kidney disease. And beyond these metabolic effects, sugar triggers reward pathways in the brain in ways that can lead to cravings and overconsumption, creating a cycle of dependency that resembles, in some respects, addiction. Salt is another example of evolutionary mismatch, though in a more nuanced way. Sodium is essential for life, regulating fluid balance, nerve function, and muscle contraction. In ancestral environments, particularly in tropical regions where early humans evolved, salt was relatively scarce. Most foods contain only small amounts of sodium. As a result, humans evolved mechanisms to conserve salt, including hormones like aldosterone that tell the kidneys to retain sodium. This made sense when salt was hard to come by, but modern diets are loaded with salt, primarily from processed and restaurant foods. The average intake far exceeds physiological needs. The same mechanisms that evolved to conserve salt now cause us to retain too much, contributing to hypertension and cardiovascular disease in salt-sensitive individuals. Public health campaigns have tried to reduce salt intake, with some success. But the food industry's reliance on salt as a cheap flavor enhancer makes this an ongoing challenge. It's worth noting that not all modern dietary changes represent mismatches. Humans have shown remarkable adaptability, and some populations have undergone genetic changes in response to dietary shifts. The evolution of lactase persistence, the ability to digest milk sugar lactose into adulthood, is a well-documented example. In populations with a long history of dairy herding, genes allowing continued lactase production became common because they provided a nutritional advantage. Similarly, populations that consumed high-starch diets, like agricultural societies dependent on grains, show increased copies of the AMI1 gene, which codes for an enzyme that breaks down starch. These genetic adaptations demonstrate that evolution can respond to dietary changes, but they take thousands of years, not decades. The dietary mismatch isn't just about what we eat, but also about how we eat. Ancestral eating was episodic and social. Meals were events, opportunities for sharing and social bonding. Food had to be prepared, often communally, and the act of preparing and eating together reinforced social ties. There was no multitasking during meals, no eating while driving or staring at a screen. Eating was a deliberate, sensory experience. In contrast, modern eating is often rushed, solitary, and mindless. We eat on the go, in our cars, at our desks. We multitask, watching television or scrolling through phones while mechanically shoveling food into our mouths. We eat not just when hungry, but out of boredom, stress, or habit. The signals of satiety, fullness, that normally regulate intake are overridden by external cues, portion sizes, advertising, and the compelling flavors of hyperpalatable foods. This disconnect between eating and awareness has consequences. Research shows that people eat more when distracted, that larger portion sizes lead to greater consumption regardless of hunger, and that the constant availability of food leads to frequent snacking, keeping insulin levels elevated and interfering with metabolic health. The rhythm of eating has also shifted. Many people now consume calories almost continuously throughout the day, a pattern very different from the more intermittent eating of ancestral populations, which likely included periods of fasting between meals. Understanding dietary mismatch doesn't mean we need to adopt a strict paleo diet or attempt to replicate exactly what our ancestors ate. That would be neither practical nor desirable. Many modern foods are nutritious and healthful. Agricultural products like whole grains, legumes, and dairy, when tolerated, can be part of a healthy diet. The goal isn't to go back, but to go forward with awareness. The principles are relatively straightforward, even if implementation in the modern food environment is challenging. Prioritize whole foods over processed ones. Eat a diverse array of plants, not just the handful of crops that dominate modern agriculture. Include healthy fats, like those found in nuts, fish, and olive oil, while limiting refined oils and trans fats. Minimize added sugars and highly refined carbohydrates. Pay attention to hunger and fullness cues rather than eating according to the clock or external prompts. Create social occasions around meals when possible, slowing down to enjoy food and company. These aren't revolutionary ideas, and they align closely with traditional dietary wisdom and public health recommendations. But framing them through the lens of evolutionary mismatch adds depth and urgency to these suggestions. It helps us understand not just that certain foods are bad in some abstract sense, but why our bodies respond to them the way they do, why we struggle with cravings and overconsumption, why the modern food environment feels so difficult to navigate. And that understanding, in turn, can motivate changes, both in individual choices and in larger policy decisions about food production, marketing, and access. Moving through time, the physical activity, mismatch. If you were to build a machine, you'd design it for the tasks it needs to perform. A car is built to transport people efficiently, its engine, transmission, and wheels all engineered for that purpose. If you then try to use that car as a stationary power generator, keeping the engine running but never actually driving it, you'd quickly encounter problems. The engine would overheat. Parts designed for use in motion would wear unevenly. Systems meant to be cooled by airflow would malfunction. The car wasn't made for sitting still. The human body is like that car. It's a machine, a biological one, designed through millions of years of evolution for movement. Our ancestors didn't sit at desks for 8 hours a day. They didn't drive to work in cars or take elevators to their offices. They moved, constantly and varied, walking, running, climbing, carrying, digging, building. And our bodies, our bones, muscles, cardiovascular system, metabolism, all evolved to function optimally under conditions of regular, sustained physical activity. When we stop moving, when we spend our days sitting, our biological systems begin to malfunction. We're using our bodies in ways they weren't designed for, and the consequences are profound. Consider the skeletal system. Bone is not static tissue. It's alive, constantly being broken down and rebuilt through a process called remodeling. When bones experience mechanical stress, like the impact of walking or the pull of muscles during exertion, cells called osteoblasts build new bone tissue, increasing density and strength. When bones experience little stress, cells called osteoclasts break down bone tissue and the balance tips toward loss. This makes evolutionary sense. Bone is metabolically expensive to maintain, requiring significant calcium and energy. In an environment where physical activity was constant, strong bones were necessary for survival. But the body doesn't waste resources building bone that isn't being used. Our ancestors maintained high bone density throughout their lives because they never stopped moving. Studies of skeletal remains from pre-agricultural populations show robust, dense bones even in older individuals. Contrast this with modern populations, particularly in wealthy, sedentary societies, where osteoporosis has become a major public health problem. Millions of people, especially post-menopausal women, suffer from brittle bones that fracture easily. Hip fractures in elderly individuals often lead to serious complications and increased mortality. While hormonal changes play a role, particularly the loss of estrogen in women, physical inactivity is a major contributor to the epidemic of osteoporosis. We're not loading our bones enough to signal to our bodies that we need them to be strong. The muscle system faces a similar issue. Muscle mass and strength are maintained through a process called muscle protein synthesis, which is stimulated by resistance, by working muscles against force. When we regularly engage in activities that challenge our muscles, lifting, carrying, climbing, the body maintains and builds muscle tissue. When we don't, muscle atrophy occurs. The body breaks down muscle protein to use elsewhere because maintaining muscle is energetically costly and, from the body's perspective, unnecessary if it's not being used. Loss of muscle mass, known as sarcopenia, is now considered almost inevitable with aging in modern societies. Yet this isn't purely a function of age. It's a function of inactivity. Studies of older adults who remain physically active show that muscle mass and function can be maintained well into later life. And when sedentary older adults begin resistance training, they can regain significant strength and muscle, even in their 70s, 80s, and 90s. The human body remains remarkably plastic, capable of adapting to new demands, but it needs those demands as signals. The cardiovascular system also evolved for activity. The heart is a muscle that grows stronger with use, like any muscle. Regular physical activity increases the efficiency of the heart, lowering resting heart rate, improving the ability to deliver oxygen to tissues, and enhancing the body's capacity to clear waste products. Blood vessels become more flexible. Endothelial function improves. Blood pressure decreases. Conversely, inactivity leads to cardiovascular deconditioning. The heart weakens. Blood pressure rises. Arterial stiffness increases, and the risk of cardiovascular disease, heart attacks, strokes, peripheral artery disease climbs dramatically. Then there's metabolism. Human metabolism evolved in a context where physical activity was inseparable from food acquisition. You had to move to eat, and you had to eat to move. This created a tight coupling between energy expenditure and energy intake. Movement stimulated various metabolic processes, improved insulin sensitivity, meaning cells responded better to insulin and took up glucose more efficiently, increased breakdown of fats for energy, regulation of appetite hormones, and reduction of inflammation. Modern life has severed this connection. We can obtain food with minimal energy expenditure, and we can spend our days expending minimal energy, sitting at desks, watching screens with convenience designed into every aspect of life. This mismatch has metabolic consequences that extend far beyond simple weight gain. Sedentary behavior is now recognized as an independent risk factor for metabolic syndrome, a cluster of conditions including insulin resistance, high blood pressure, abnormal cholesterol levels, and abdominal obesity. Even people who exercise regularly but spend the rest of their day sitting face increased risks compared to those who are active throughout the day. There's a growing recognition that sitting itself is harmful, that our bodies need frequent movement, not just a concentrated bout of exercise followed by hours of stillness. The impact of physical inactivity on mental health is equally significant, though perhaps less obvious. Exercise has powerful effects on the brain. Physical activity increases blood flow to the brain, promotes the growth of new neurons, particularly in the hippocampus, a region critical for memory and mood. Regulation enhances the production of neurotrophic factors that support brain health and stimulates the release of endorphins and other neurotransmitters that improve mood. Regular exercise has been shown in numerous studies to reduce symptoms of depression and anxiety, with effects comparable to medication in many cases. It improves sleep, cognitive function, and stress resilience. Our ancestors didn't need to exercise for mental health. The movement required for survival provided these benefits automatically. But in our sedentary modern world, the absence of movement creates a void. We lose not just the physical benefits of activity, but also the mental and emotional ones. This may contribute to the high rates of depression and anxiety in modern societies, particularly in highly developed, technologically advanced nations where physical activity has been most thoroughly engineered out of daily life. Understanding the physical activity mismatch also helps explain why modern exercise can feel so difficult, even unpleasant, to many people. We talk about exercise as something we should do, a chore, an obligation, often something we dread. But our ancestors didn't think of movement this way. They didn't have a category for exercise as distinct from the rest of life. They moved because it was necessary, because it was woven into the activities that gave their lives meaning, providing food, building shelter, traveling to new places, playing, dancing. Movement had purpose and social context. In contrast, much modern exercise is removed from any immediate purpose. We go to gyms and walk on treadmills, going nowhere. We lift weights and put them back down. We perform repetitive motions in isolation. There's no gathering of food, no building of shelter, no social goal. It's movement for movement's sake. And while intellectually we understand it's good for us, our brains don't find it inherently motivating the way purposeful movement would be. This is not to say that gyms and structured exercise are useless. They clearly provide benefits, but it helps explain why adherence to exercise programs is so poor, why most people who start workout routines quickly abandon them. So what does this mean for how we should think about physical activity? The evolutionary perspective suggests several principles. First, aim for frequent, varied movement throughout the day, rather than just isolated bouts of intense exercise. While structured workouts have value, they don't fully compensate for prolonged sitting. Look for opportunities to move in daily life. Take stairs instead of elevators. Walk or bike instead of driving when possible. Stand or pace during phone calls. Take breaks from sitting every hour. Second, incorporate activities that involve natural human movements. Walking, running, climbing, lifting, carrying, throwing. These are the movement patterns our bodies evolved to perform, and they engage multiple muscle groups in coordinated ways. Sports, dance, martial arts, yoga, and outdoor activities like hiking or gardening can provide this kind of varied, purposeful movement. Third, make movement social when possible. Exercise with friends or family, join recreational sports leagues, take group fitness classes. The social aspect adds motivation and meaning that align with how our ancestors would have experienced physical activity, as part of community life rather than as solitary obligation. Fourth, spend time outdoors. Movement in natural environments provides additional benefits beyond the physical activity itself. Exposure to natural light, varied terrain that challenges balance and proprioception, psychological benefits of nature contact, and the opportunity for the kind of exploratory movement that characterized ancestral life. Finally, recognize that the goal isn't to recreate exactly what our ancestors did. We don't need to hunt game or forage for plants, assuming we even could. But we can acknowledge that our bodies were made to move, and that reclaiming movement as a central part of daily life, rather than an optional add-on, is essential for health. This might require restructuring aspects of our lives, choosing active transportation, designing workspaces that encourage movement, limiting screen time that keeps us sedentary. At a societal level, addressing the physical activity mismatch requires rethinking how we've built our modern world. Our cities and suburbs are designed for cars, making walking and cycling difficult or dangerous. Our schools have cut physical education and recess to make room for more academic instruction, despite evidence that physical activity enhances learning. Our workplaces are designed around sitting, with jobs that require 8 or more hours at a desk. Our entertainment is increasingly screen-based and sedentary. These are design choices, not inevitable features of modern life. We could design cities with walkable neighborhoods, protected bike lanes, accessible parks, and green spaces. We could design schools that prioritize movement breaks and active play. We could design workplaces with standing desks, walking meetings, and on-site fitness facilities. Some progressive companies and communities are already making these changes, recognizing that the health costs of inactivity are unsustainable. The physical activity mismatch is one of the clearest examples of how our modern environment has diverged from our evolutionary needs. Our bodies are sophisticated machines designed for motion, and we've created a world that allows, even encourages, stillness. The consequences, obesity, diabetes, cardiovascular disease, osteoporosis, depression, are written across the health statistics of developed nations. But unlike some aspects of evolutionary mismatch, this one has a relatively straightforward solution. Move more. The challenge is implementation, building movement back into lives and societies structured around convenience and efficiency. But the biology is clear. We were made to move, and when we don't, we suffer. Chasing shadows, sleep, and light. Few aspects of our daily lives seem as mundane as turning on a light switch or checking our phones before bed. These actions are so routine, so thoroughly woven into the fabric of modern existence, that we rarely pause to consider how profoundly they've altered a fundamental aspect of human biology: our relationship with light and darkness, and consequently, our sleep. Yet this relationship, shaped over hundreds of thousands of years of evolution, has been revolutionized in barely more than a century, and the mismatch between our ancient circadian biology and our modern light environment is implicated in a growing list of health problems, from insomnia to depression, from metabolic disorders to increased cancer risk. To understand the depth of this mismatch, we need to go back to the environment that shaped human sleep. For the overwhelming majority of human evolutionary history, light came from a single source: the sun. Days were defined by its presence, nights by its absence. The only artificial light available was fire, which produces a warm, orange-red spectrum of light that's relatively weak compared to daylight, and, crucially, doesn't contain much blue light, the wavelength that most powerfully affects our internal biological clock. Human circadian rhythms, the approximately 24-hour cycles that regulate sleep, hormone production, body temperature, and countless other physiological processes, evolved to synchronize with this natural pattern of light and dark. At the heart of this system is a small region in the brain called the suprachiasmatic nucleus, located in the hypothalamus. This master clock receives input from special photoreceptor cells in the retina that detect light, particularly blue light wavelengths around 480 nanometers, and use that information to adjust the timing of circadian rhythms, a process called entrainment. In ancestral environments, this system worked beautifully. Sunrise provided a strong signal. Daylight is here. It's time to be awake and active. The bright daytime light, thousands of times more intense than typical indoor lighting, kept the circadian system firmly anchored to the solar day. As evening approached and light faded, the absence of bright light signaled the pineal gland to begin producing melatonin, a hormone that promotes sleepiness and initiates a cascade of other nighttime processes. People would go to sleep a few hours after sunset, sleep for a period, and wake naturally around dawn. The cycle was stable, predictable, aligned with the environment. This alignment had profound implications for sleep quality. Research on pre-industrial populations, groups living without electricity in traditional settings, shows that their circadian rhythms are strongly synchronized. When measured using melatonin secretion as a marker, these populations show melatonin onset occurring consistently and earlier in the evening than in industrialized populations. Their sleep timing is less variable from night to night. They don't exhibit the phenomenon known as social jet lag, the mismatch between biological sleep timing and social schedules that affects millions of people in modern societies. Then came artificial light. The progression happened in stages. First, oil lamps and gas lighting in the 19th century, allowing people to extend their waking hours past sunset. Then, in the late 19th and early 20th centuries, electric lighting, which was brighter, safer, more convenient, and quickly became ubiquitous. By the mid-20th century, electric light was everywhere in developed nations, indoors and outdoors, transforming night into an extension of day. This was celebrated as progress, and in many ways, it was. Artificial light enabled education, productivity, culture, and entertainment after dark. It made homes safer and streets more secure. But it also introduced an unprecedented disruption to human circadian biology. For the first time in history, people could be exposed to bright light at any hour. Gradually, sleep timing began to shift later. People stayed up past their natural bedtime, kept awake by the alerting effects of artificial light. And because social schedules, work, school, remained tied to solar time, requiring people to wake at specific times in the morning, this late sleep onset wasn't offset by later wake times. The result was chronic sleep restriction, a shortening of total sleep duration that has become endemic in modern societies. But the problem isn't just about the quantity of sleep, it's also about the quality and the timing. The type of light matters enormously. The LEDs in our phones, tablets, laptops, and televisions emit significant amounts of blue light, the very wavelength that most powerfully signals to the circadian system that it's daytime. When we expose ourselves to these screens in the evening, we're essentially telling our brains that the sun is still up. This suppresses melatonin production, delays the biological night, shifts circadian timing later, and makes it harder to fall asleep. Studies have shown that even a couple of hours of evening exposure to bright screens can delay melatonin onset by an hour or more. The variability of light exposure in modern life also creates problems, because we can control our light environment, choosing when to turn lights on or off. Our exposure patterns can vary dramatically from day to day. One night you might stay up late under bright lights, watching television or scrolling through social media. The next night you might go to bed earlier. This variability prevents stable entrainment of circadian rhythms. Your biological clock doesn't know what time it really is, leading to what researchers call circadian misalignment, a state where your internal rhythms are out of sync with your actual sleep schedule and the external environment. Compounding this problem is that modern people spend far less time exposed to bright daylight. Studies show that people in industrialized societies spend more than 90% of their time indoors. where light levels are typically between 100 and 500 lux, orders of magnitude dimmer than outdoor daylight, which can range from 10,000 to 100,000 lux. This dim daytime light provides a weak signal to the circadian system, reducing its ability to stay strongly entrained to the solar day. So we have dim days and bright nights, exactly the opposite of the pattern that prevailed for most of human history. The consequences of this circadian disruption are far-reaching. At the most immediate level, there's sleep itself. Insomnia is now remarkably common in industrialized societies, affecting anywhere from 10 to 30% of the population, depending on how it's measured, while it's virtually absent in pre-industrial populations. Sleep apnea, a condition where breathing repeatedly stops and starts during sleep, has reached epidemic proportions, affecting over 1 billion people worldwide. Obesity contributes to sleep apnea, but the relationship goes both ways. Poor sleep also contributes to obesity by disrupting appetite hormones and increasing cravings for high-calorie foods. Beyond sleep problems, circadian misalignment affects a wide array of physiological processes. Metabolism is circadian, with insulin sensitivity, glucose tolerance, and fat metabolism, all showing daily rhythms that are coordinated by the circadian clock. When sleep timing is misaligned with circadian biology, these metabolic processes become disrupted, increasing the risk of obesity, type 2 diabetes, and metabolic syndrome. Immune function is also circadian, with certain immune responses stronger at certain times of day. Disrupted circadian rhythms impair immune function, increasing susceptibility to infections and inflammation. Mental health is profoundly affected by light and circadian rhythms. The link between sleep and mood has long been recognized, but we now understand that the relationship is mediated by circadian biology. Circadian misalignment is associated with increased risk of depression, anxiety, and mood disorders. This may be one reason why seasonal affective disorder occurs, with people becoming depressed during winter months when days are short and exposure to bright light is reduced. It may also help explain the high rates of depression in modern societies generally, where circadian disruption is endemic. There's even evidence linking circadian disruption to increased cancer risk. Studies of shift workers who experience chronic circadian misalignment show elevated rates of breast cancer, prostate cancer, and colorectal cancer. The mechanisms likely involve melatonin, which has anti-cancer properties, disruption of DNA repair processes that follow circadian rhythms, and immune dysfunction. The International Agency for Research on Cancer has classified shift work involving circadian disruption as a probable carcinogen. The impact on children and adolescents deserves special attention. Teenagers experience a natural shift in circadian timing during puberty, becoming biologically predisposed to stay up later and wake later, a phenomenon called delayed sleep phase. This is likely an evolved adaptation, possibly serving functions related to adolescent development and social bonding. But modern school schedules force teenagers to wake early, often before their biological night has ended. This creates massive sleep deprivation among adolescents, with surveys showing that the majority of high school students get far less than the recommended 8 to 10 hours of sleep. The consequences include impaired academic performance, increased mental health problems, higher rates of car accidents, and obesity. Understanding the evolutionary mismatch around light and sleep suggests several interventions. At the individual level, people can take steps to realign their light exposure with ancestral patterns. This means seeking bright light, ideally natural sunlight during the day, especially in the morning. Even 15 to 30 minutes of outdoor exposure in the morning can help anchor circadian rhythms. During the day, try to spend time near windows, or better yet, take breaks outside. The goal is to give your circadian system a strong signal about when it's daytime. In the evening, the strategy is to dim the lights and reduce exposure to blue light. This doesn't mean sitting in darkness, but it does mean being thoughtful about lighting choices. Use dim, warm-colored lights in the hours before bed. If you use screens in the evening, enable night mode or blue light filtering features that shift the color spectrum toward warmer tones. Better yet, establish a screen-free period before bed, using that time for activities like reading physical books, talking with family, or preparing for the next day. Blackout curtains or eye masks can help ensure darkness during sleep, which is important for melatonin production and sleep quality. Regular sleep schedules help maintain circadian alignment. Going to bed and waking up at roughly the same time each day, even on weekends, allows your circadian system to stabilize. This is challenging in modern life, where social obligations, work schedules, and personal preferences often conflict with biological timing. But within those constraints, consistency helps. At the societal level, addressing the light and sleep mismatch requires policy changes. School start times, particularly for adolescents, should be adjusted to align with teenage circadian biology. Several school districts that have implemented later start times have seen improvements in attendance, academic performance, and mental health. Workplace policies could be more flexible about hours, allowing people to align work schedules with their natural chronotypes, recognizing that some people are morning types, while others are evening types. Lighting standards could prioritize circadian health, using brighter, blue-enriched light during the day in offices and schools, and dimmer, warmer light in the evening. The outdoor lighting environment also matters. Light pollution from streetlights, buildings, and advertising has made truly dark nights increasingly rare, even in suburban and rural areas. This ambient light disrupts circadian rhythms and affects wildlife as well as humans. Some communities are beginning to implement dark sky initiatives, using shielded lighting that directs light downward rather than into the sky, and turning off unnecessary lights at night. The light and sleep mismatch illustrates how a technological innovation, artificial lighting, that brought enormous benefits, has also created unintended health consequences by disrupting ancient biological systems. We can't and shouldn't abandon electric light, but we can use it more thoughtfully, designing our light environment to work with our biology rather than against it, preserving the darkness that our bodies need to maintain health. Digital disconnection, social bonds in the modern age. Human beings are profoundly social creatures. Our success as a species has been built on our ability to cooperate, communicate, form complex relationships, and work together toward common goals. The human brain, with its enormous prefrontal cortex and sophisticated theory of mind abilities, evolved largely to navigate social environments. We are wired to connect, to read faces, to interpret tone of voice, to understand subtle social cues, to form attachments, to care about our standing within groups. This social nature isn't a luxury or an add-on to our biology. It's central to who we are, and it shaped every aspect of our evolutionary history. For most of human existence, social life meant face-to-face interaction within small, stable groups. As we discussed earlier, hunter-gatherer bands typically consisted of 25 to 150 people, individuals you knew intimately, whose faces, voices, histories, and personalities were deeply familiar. These were your relatives, your lifelong companions, the people with whom you shared food, shelter, child-rearing, joy, and grief. Social bonds were formed through constant proximity, through shared experiences, through working together on tasks essential for survival. Relationships in these groups were multidimensional. You didn't just see someone in one context, as a co-worker or a casual acquaintance. You saw them in all their complexity, as a skilled hunter perhaps, but also as a storyteller, a parent, a friend, someone who had fears and strengths, someone who had helped you in the past and might need your help in the future. There was accountability, what anthropologists call reputational concern. Your actions mattered because everyone would know about them. You couldn't escape your reputation. This created strong incentives for cooperation, generosity, fairness, and trustworthiness. The quality of social bonds in these settings was also different from much of what we experience today. Relationships developed slowly, over years and decades of repeated interactions. Trust was earned through demonstrated reliability. Intimacy deepened through shared hardship and celebration. There was no quick way to forge a relationship. You couldn't add someone as a friend with a click. You had to spend time together, work together, communicate directly. And because the group was small, every relationship mattered. Losing social standing or being ostracized could be devastating, potentially threatening survival. This social environment shaped our psychology in profound ways. We evolved emotions specifically designed to facilitate cooperation and maintain relationships. Empathy, allowing us to understand others' feelings. Guilt, motivating us to repair relationships after transgressions. Shame, signaling awareness of social violations. Gratitude, reinforcing bonds with those who help us. Anger, responding to violations of fairness. We developed complex communication abilities, including language, enabling the sharing of information and coordination of activities far beyond what's possible for other species. We became attuned to social hierarchies, status signals, and the intricate dance of social politics. Crucially, we also evolved needs for social connection that operate at a deep biological level. Loneliness, the painful feeling of social isolation, isn't just a psychological state. It triggers physiological stress responses, elevating cortisol, increasing inflammation, and suppressing immune function. The evolutionary logic is clear. Being socially isolated in ancestral environments was dangerous. Without the support and protection of a group, individuals faced increased risk of predation, starvation, and inability to reproduce. Loneliness served as a signal, a painful warning that you needed to reconnect with your social group. It motivated people to repair relationships and maintain bonds. The flip side is that social connection activates reward systems in the brain. Positive social interactions release oxytocin, dopamine, and endorphins, creating feelings of pleasure, bonding, and well-being. Holding hands with a loved one reduces stress and pain. Sharing laughter strengthens relationships. Being seen, understood, and valued by others fulfills fundamental psychological needs. In the words of psychologist John Cacioppo, who spent his career studying loneliness, humans have a biological need for social connection that's as fundamental as the need for food or water. Now fast forward to the 21st century. The Industrial Revolution and urbanization had already begun to transform social life, breaking up extended family networks, moving people from tight-knit rural communities to anonymous cities, creating work, environments where people might spend their days with strangers. But the digital revolution has accelerated these changes in unprecedented ways. Social media platforms promise connection. They allow us to stay in touch with hundreds or even thousands of people. We can share updates, photos, thoughts instantly with vast audiences. We can maintain relationships across distances that would have severed them completely in the past. We have access to communities of people who share our interests, no matter how niche. The potential seems limitless. Yet despite, or perhaps because of, this connectivity, rates of loneliness have been climbing steadily. Surveys across multiple countries show that more people report feeling lonely, isolated, and lacking meaningful social connections than in past generations. Young people, the most active users of social media, report particularly high rates of loneliness and related mental health problems. How can this be? How can we be more connected than ever yet feel more alone? The answer lies in the evolutionary mismatch between our social psychology and the nature of digital connection. The kind of connection that social media provides is fundamentally different from the face-to-face, embodied, multi-sensory interaction for which we evolved. When you communicate with someone in person, you're receiving a rich stream of information: facial expressions, body language, tone of voice, timing and rhythm of speech, physical proximity, even pheromones. Your brain processes all of this unconsciously, building a detailed model of the other person's emotional state, intentions, and meaning. This is what our social cognitive systems are designed to do: Digital communication strips away most of these signals. Text messages provide words alone, no tone, no expression, no body language. Even video calls, while better, still lack the full richness of in-person interaction. There's a flatness, a slight delay, a sense of distance that remains. Our brains recognize that something is missing, and the relationships formed or maintained through primarily digital means often feel less satisfying, less real than face-to-face relationships. This is especially true for what researchers call weak ties, the casual acquaintances and broader network connections that make up much of our social media interactions. While weak ties have value, providing access to information and opportunities, they don't fulfill our deep need for close, intimate relationships. Moreover, social media introduces new problems that have no parallel in ancestral social environments. One is the phenomenon of social comparison. Humans have always compared themselves to others. That's part of how we evaluate our own status and success. But historically, this comparison was limited to the people immediately around you, your band, maybe a few neighboring bands, and you saw these people in all their complexity, their struggles, as well as their successes. Social media dramatically expands the scope of social comparison while simultaneously distorting it. You're now comparing yourself not to 30 people you know well, but to hundreds or thousands of people whose lives you see only through carefully curated highlights. People post their successes, their vacations, their happy moments, but rarely their struggles, failures, or ordinary, mundane experiences. This creates an unrealistic picture that can make your own life seem inadequate by comparison. Research consistently shows that social media use is associated with increased depression, anxiety, and low self-esteem, particularly among adolescents. The constant comparison, the pressure to present a perfect image, the metrics of likes and followers as proxies for social worth, all contribute to psychological distress. Another problem is the asynchronous, scalable nature of digital communication. In face-to-face settings, conversations happen in real time with a small number of people. If you say something hurtful, you see the immediate impact on the other person's face. If you misunderstand something, you can clarify right away. The back-and-forth nature of conversation allows for nuance, repair, and connection. Online, conversations happen asynchronously and often publicly. You post something, and responses might come hours or days later. Misunderstandings proliferate because text lacks tone. What was meant as a joke can be read as an insult. What was meant as a casual comment can be interpreted as a deep statement. And because these exchanges often happen in front of an audience, people perform for that audience rather than communicating authentically with each other. The scalability means that a single post can reach thousands or millions, far beyond anything possible in ancestral settings. And the responses can range from supportive to viciously hostile, with little middle ground. The phenomenon of online harassment, cyberbullying, and what's been called context collapse, where messages intended for one audience are seen by entirely different audiences with different norms, are all products of this mismatch. Our social cognition evolved for small-scale, face-to-face interaction. We're not psychologically equipped to handle the scale, speed, and public nature of social media communication. It overwhelms our capacity to maintain appropriate boundaries, manage reputation, and regulate our emotional responses. Then there's the issue of attention. Social media platforms are designed, quite deliberately, to capture and hold attention. They use sophisticated algorithms to show you content that's likely to engage you, to keep you scrolling, to bring you back frequently. The business model depends on it. The problem is that our attention is finite, and time spent on social media is time not spent on other activities, including face-to-face interaction. Studies show that people who spend more time on social media tend to spend less time in person with friends and family. The superficial abundance of digital connection may actually be crowding out deeper, more meaningful forms of connection. This is particularly concerning for children and adolescents, whose brains are still developing and who are especially vulnerable to social feedback. The teenage years are a critical period for social development, when people learn to navigate complex relationships, form identities, and develop autonomy. Historically, this happened through face-to-face interaction with peers, with all the awkwardness, conflict, and growth that entails. Now, much of teenage social life happens online, mediated by platforms that distort social dynamics and provide constant opportunities for rejection, exclusion, and comparison. The mental health consequences appear to be substantial, with rising rates of depression, anxiety, and suicide among adolescents correlating with the rise of social media. The evolutionary mismatch in social connection also extends to the structure of modern communities. We live in a world of high mobility, where people frequently move for education, jobs, or other opportunities. The average American moves more than 11 times in their lifetime. This mobility has benefits: flexibility, new experiences, economic opportunity, but it also means that many people lack the stable, long-term social networks that characterized ancestral life. You might form close friendships in one place, then move and have to start over, building new relationships from scratch. The effort required is considerable, and many people end up somewhat socially isolated, with acquaintances, but few deep bonds. Work structures contribute to this problem. Many modern jobs involve interaction with co-workers, but these relationships are often superficial and instrumental, based on professional roles rather than whole persons. Remote work, which has become much more common, further reduces face-to-face contact. Commuting culture means people live far from where they work, separating home and work communities. The intensity of work schedules leaves little time for socializing outside of work. All of these factors reduce opportunities for the kind of repeated, face-to-face, multidimensional interactions that build strong social bonds. So what does the evolutionary perspective suggest we do about this social mismatch? At the individual level, the prescription is to prioritize in-person connection over digital communication whenever possible. This doesn't mean abandoning social media or digital tools entirely. They have genuine utility for staying in touch and accessing information, but it does mean being intentional about how you use them. Limit time on social media. When you do use it, focus on connecting with people you actually know rather than endlessly scrolling through strangers' content. Use digital tools to facilitate in-person meetups rather than as substitutes for them. Reach out to friends and family to make plans. Go for walks. Share meals. Have conversations without phones present. Invest in building and maintaining close relationships. Quality matters more than quantity. Having a few deep, trusting relationships is far more important for well-being than having hundreds of superficial connections. This requires time and effort. Relationships need to be nurtured through regular contact, mutual support, vulnerability, and shared experiences. Make this a priority, even when it feels hard, or when other demands compete for attention. Seek out community in physical spaces. Join clubs, teams, volunteer organizations, religious congregations, classes, anything that brings you into regular contact with the same group of people over time. These kinds of repeated interactions allow relationships to develop naturally and build a sense of belonging. Be present in your neighborhood, get to know neighbors, support local businesses, participate in community events. For parents, think carefully about children's, and especially adolescents' use of social media and screens. This is a contentious area, and different families will make different choices, but the evidence suggests that heavy social media use during the teenage years is harmful. Consider delaying smartphone access, limiting screen time, and creating spaces for face-to-face socializing. Encourage activities that involve direct interaction, sports, arts, outdoor play, family time. Model healthy relationship behaviors, putting away your own phone to be present with family. At the societal level, we need to rethink how digital platforms are designed and regulated. The current incentive structure, where platforms profit from engagement regardless of whether that engagement is healthy or harmful, is problematic. Regulations that protect children, limit manipulative design features, and promote transparency about algorithmic content selection could help. Supporting public spaces, community centers, parks, and other venues for face-to-face interaction is also important. The social connection mismatch reminds us that humans are not meant to be isolated individuals, interacting primarily through screens. We're deeply social beings who need regular, rich, face-to-face contact to thrive. The digital age has brought us new tools for communication, but if we're not careful, these tools can end up making us lonelier, not more connected. Recognizing this mismatch is the first step toward reclaiming the depth of social connection that our biology craves. The anxious mind, mental health in modern times. Walk into any mental health clinic, flip through the pages of any psychiatry journal, look at the statistics on mental illness in developed nations, and you'll see a picture that's deeply troubling. Depression affects more than 300 million people worldwide. Anxiety disorders are even more common, affecting roughly 1 in 10 people. Rates of these conditions have been climbing, particularly among young people. Suicide is now the second leading cause of death among adolescents and young adults globally. The burden of mental illness, measured in disability-adjusted life years, rivals or exceeds that of physical diseases. Something is clearly wrong. And while mental illness has biological and genetic components, while individual brains vary in their vulnerability to psychiatric disorders, the sharp rise in mental health problems in recent decades, occurring too quickly for genetic changes, points to environmental factors. The evolutionary mismatch framework offers a lens for understanding these environmental factors. It suggests that many forms of mental distress arise from the disconnect between the environments we evolved to inhabit and the environments most of us actually inhabit today. Consider anxiety, one of the most common forms of mental suffering. From an evolutionary perspective, anxiety is not a malfunction. It's a protective response, designed to help us avoid danger. When we perceive a threat, our amygdala, a brain structure involved in processing fear, triggers the stress response. Cortisol and adrenaline flood the bloodstream, heart rate increases, breathing quickens, muscles tense, attention narrows to focus on the threat. This is the fight or flight response, and it served our ancestors well when facing immediate physical dangers. Predators, hostile individuals, environmental hazards. The key word is immediate. In ancestral environments, threats were typically acute and physical. A lion appears, you feel intense fear and anxiety, you run or fight. The threat resolves one way or another, and your stress response de-escalates. Your anxiety served its purpose. It motivated you to take protective action, and once the danger passed, you returned to baseline. Modern threats are different. We rarely face lions or immediate physical violence in daily life, at least in most parts of developed nations, but we face an overwhelming array of chronic, psychological threats, job insecurity, financial stress, social rejection, information overload, environmental concerns, political instability, health worries. These threats are not brief and discrete. They're ongoing and diffuse. You can't run from them or fight them in any simple physical sense. They persist in the background of your mind, creating chronic activation of stress response systems. This chronic stress is deeply problematic. The stress response evolved for short-term activation. Cortisol is helpful in brief bursts, mobilizing energy and enhancing focus. But chronic elevation of cortisol has harmful effects. It suppresses immune function, increases inflammation, impairs memory and learning, disrupts sleep, promotes fat storage, particularly in the abdomen, and damages brain structures, including the hippocampus. Prolonged anxiety and stress create a vicious cycle, where the stress response itself becomes a source of further stress and dysfunction. Moreover, the modern world bombards us with information about potential threats far beyond our immediate experience. Through news media, social media, and constant connectivity, we're aware of disasters, crimes, injustices, and dangers happening all over the world. Our ancestors would have known about threats in their immediate environment, but not about every plane crash, every terrorist attack, every disease outbreak happening globally. This constant stream of alarming information, often sensationalized for attention, keeps our threat detection systems on high alert, even though most of these threats don't actually affect us personally. The anxiety mismatch is particularly evident in social anxiety. Humans evolved a healthy concern for social evaluation because our social standing mattered for survival. Being excluded from the group was potentially deadly, so we developed sensitivity to social threats: rejection, humiliation, loss of status. This sensitivity motivated us to behave in ways that maintained social bonds and reputation. But this sensitivity was calibrated for small groups where you knew everyone and they knew you. In the modern world, we're exposed to far more social evaluation than our psychology is equipped to handle. Social media makes our presentations of self visible to hundreds or thousands. We're constantly aware of how we're being perceived, how many likes we're getting, who's paying attention to us. The stakes feel high, even though rationally, we know that the opinion of random strangers shouldn't matter as much as the opinions of people we actually know and care about. The result is epidemic levels of social anxiety, with people feeling constantly judged and inadequate. Depression, too, can be understood partly through the evolutionary mismatch lens. This is more complex and controversial because depression is multifaceted and clearly has genetic and neurobiological components. But there are evolutionary theories of depression that are worth considering. One, the social rank theory, suggests that depression can be triggered by experiences of defeat, loss of status, or prolonged inability to achieve goals. The feelings of worthlessness, hopelessness, and withdrawal that characterize depression might have evolved as responses to situations where continued striving would be futile or dangerous, like when you've lost a dominance contest and need to submit to avoid further harm. Another theory, the social navigation hypothesis, proposes that depression functions as a signal, both to others that you need help and to yourself that something in your life situation needs to change. The rumination that characterizes depression, the endless turning over of problems, might be an attempt by the brain to solve unsolvable problems or process complex social difficulties. Whether or not these theories fully explain depression, it's clear that certain features of modern life increase depression risk. Social isolation and loneliness, as we discussed, have risen sharply and are strong predictors of depression. Lack of physical activity deprives people of the mood-enhancing effects of exercise. Poor sleep disrupts mood regulation. Chronic stress and anxiety create learned helplessness, a sense that one can't control or escape negative outcomes. The loss of meaning and purpose that can come from unfulfilling work or lack of clear life goals may also contribute. Interestingly, depression appears to be less common in some traditional societies, though this is difficult to measure due to cultural differences in how emotional distress is expressed and understood. But ethnographic accounts and cross-cultural studies suggest that severe, prolonged depression is relatively rare in many hunter-gatherer and subsistence farming communities. When it does occur, it's often in response to clear precipitating events: loss of a loved one, serious illness, social conflict, and the social support systems in these communities, with extended family and community involvement, may buffer against some forms of psychological distress. Another aspect of the mental health mismatch involves what psychologists call purpose and meaning. Humans seem to have a deep need to feel that their lives matter, that they're contributing to something beyond themselves. In ancestral environments, purpose was built into daily life. Your activities, gathering food, caring for children, participating in group rituals, were clearly essential for survival and community well-being. You could see the direct impact of your efforts. Modern life, especially for those in repetitive, bureaucratic, or seemingly meaningless jobs, can lack this sense of purpose. You might spend your days in a cubicle generating reports that nobody reads, or performing customer service tasks that feel Sisyphean. The existential question, "What's the point?" becomes harder to answer. This lack of purpose is compounded by the overwhelming array of choices and possibilities in modern life. Psychologist Barry Schwartz has written about the paradox of choice, the idea that while having options is generally good, too many options can lead to anxiety, dissatisfaction, and paralysis. Our ancestors had limited choices about how to live. Their paths were largely determined by their birth, their environment, and the needs of survival. This had obvious drawbacks, limiting freedom and autonomy. But it also provided clarity. You knew what was expected of you, what your role was, how to contribute. Modern life offers extraordinary freedom, but also extraordinary uncertainty. You have to choose a career from thousands of options, decide where to live, determine what kind of relationships to pursue, figure out your values and identity. These choices can be empowering, but they can also be overwhelming, especially when combined with the constant comparison to others who seem to have made better choices. The German sociologist Hartmut Rosa has argued that modern life is characterized by a crisis of resonance, a feeling that despite all our options and technologies, we're unable to form meaningful connections with the world around us. The mental health mismatch also involves our capacity for managing information. The human brain evolved to process information from the immediate environment, the dozen or so people in your band, the local landscape, the animals and plants you encountered. Modern information technology exposes us to vastly more information than we can possibly process. We're aware of thousands of people's lives, global events, complex problems. We're expected to have opinions on everything, to stay informed, to keep up. The cognitive load is immense. Moreover, the information environment is often toxic. Algorithms optimize for engagement, not for well-being, and engagement is most easily achieved through content that provokes strong emotions: outrage, fear, envy. News media emphasizes negative events because they grab attention. Social media filters create echo chambers that amplify extreme views and tribalism. The overall effect is an information ecosystem that promotes anxiety, polarization, and distorted perceptions of reality. So what can be done? At the individual level, protecting mental health in the modern world requires conscious effort to counter the mismatches. This includes many of the strategies already discussed: prioritizing face-to-face social connection, engaging in regular physical activity, maintaining healthy sleep habits, spending time in nature. But it also involves more specific mental health practices. Mindfulness and meditation, while often presented in spiritual terms, can be understood as tools for managing the mismatch between our threat detection systems and modern stressors. These practices help people observe their thoughts and emotions without being overwhelmed by them, creating distance between experiencing anxiety and being defined by anxiety. Cognitive behavioral therapy similarly helps people recognize and challenge distorted thinking patterns that amplify distress. Limiting exposure to information overload is important. This might mean restricting news consumption, unfollowing accounts that provoke negative emotions, setting boundaries around work emails and messages, creating periods of disconnection, times when you're not plugged into the global information stream, allows your nervous system to settle. Finding purpose and meaning, even in a world that doesn't provide them automatically, is crucial for mental health. This might involve creative pursuits, volunteer work, spiritual practice, or simply being very present and engaged in relationships and daily activities. The key is to identify what matters to you and structure your life around those values, rather than living reactively, responding to whatever demands the world throws at you. For those struggling with serious mental illness, professional help is essential. Therapy, and when appropriate, medication can be life-changing. The evolutionary perspective doesn't negate the reality of mental illness or the need for treatment, but it can provide context, helping people understand that their suffering isn't just a personal failing or a random malfunction, but often a response to a mismatch between their biology and their environment. At the societal level, addressing the mental health mismatch requires structural changes. This includes reducing the economic stresses that create chronic anxiety for millions: job insecurity, lack of access to healthcare, unaffordable housing, student debt. It includes reforming education to focus less on competitive pressure and more on well-being and character development. It includes creating community structures that foster belonging and purpose. And it includes rethinking how digital platforms and media operate, prioritizing well-being over engagement. The mental health crisis in modern societies is not inevitable. It's a product of specific environmental conditions that can be changed. Understanding the evolutionary roots of psychological suffering gives us a framework for making those changes, both in our individual lives and in our collective institutions. Workplace wilderness, modern work versus ancestral labor. Work is central to human life. For most of human history, work meant the activities necessary for survival: finding food, building shelter, creating tools, caring for children. These activities weren't separate from the rest of life. They were interwoven with social relationships, physical movement, direct contact with nature, and a clear sense of purpose. The fruits of one's labor were immediate and tangible. You gathered berries and you ate them. You built a shelter and you slept in it. Modern work is radically different. For most people in industrialized economies, work means spending 8 or more hours a day performing tasks that bear little resemblance to anything their ancestors did. You sit at a desk, stare at a screen, manipulate symbols, abstract representations of value and information. The connection between your efforts and any tangible outcome is often obscure. You might work on a small piece of a large project, never seeing the end result. You're compensated with money, itself an abstraction, which you then exchange for goods and services produced by other people you'll never meet. This transformation of work represents another significant evolutionary mismatch, and it contributes to widespread feelings of dissatisfaction, stress, and meaninglessness. Surveys consistently show that large percentages of workers report feeling disengaged from their jobs. In a Gallup poll, roughly 65% of employees worldwide reported being not engaged or actively disengaged at work. Burnout, characterized by emotional exhaustion, cynicism, and reduced professional efficacy, has reached epidemic levels in many professions, particularly in healthcare, education, and service industries. The mismatch begins with the sedentary nature of most modern office work. As we discussed in the physical activity section, humans evolved to move. Our ancestors' work was physically demanding, walking, carrying, bending, lifting throughout the day. This movement was not just incidental, it was integral to the tasks themselves and provided the physical and mental health benefits that come from regular activity. Contrast this with sitting in a chair for 8 hours, typing on a keyboard. The physical immobility contributes to musculoskeletal problems, back pain, neck strain, repetitive strain injuries. It deprives us of the mood-enhancing and stress-reducing effects of movement. It leads to metabolic dysfunction. Our bodies simply aren't designed for this level of inactivity, yet we've structured work to require it. The cognitive demands of modern work also create mismatches. Many jobs involve sustained attention to computer screens, processing large amounts of information, responding to constant interruptions from emails, messages, and notifications. This creates cognitive overload and attention fatigue. Human attention evolved to be flexible, shifting between broad awareness of the environment and focused attention on specific tasks as needed. We're good at noticing changes, responding to novelty, and taking breaks when needed. Modern work environments, especially those involving knowledge work, demand sustained focus on abstract tasks for hours at a time, often in environments filled with distractions. The open office layout, popular in many companies, exemplifies this problem. While intended to facilitate collaboration, these spaces often create constant noise and visual distraction, making deep focus nearly impossible. Workers resort to headphones and other coping strategies, but the fundamental mismatch remains. The hierarchical structure of many modern workplaces also differs from ancestral social structures. As we discussed earlier, hunter-gatherer societies were relatively egalitarian. Leadership was situational and earned through competence. There were no distant bosses or multi-layered bureaucracies. You worked alongside people you knew well, and your contributions were visible and appreciated. In contrast, many modern workers labor within large, impersonal organizations with complex hierarchies. You might report to a manager you barely know, who reports to executives you've never met, working for shareholders you'll never see. Your specific contributions may feel insignificant within the vast machinery of the organization. This lack of direct connection and recognition can undermine motivation and satisfaction. Moreover, the nature of authority in many workplaces can trigger stress responses. Humans evolved sensitivity to social dominance because our position within group hierarchies affected our access to resources and mates. Being subjected to arbitrary or capricious authority activates threat responses. Studies show that workers with little control over their work, who must follow orders without autonomy, experience higher stress and worse health outcomes compared to workers with more autonomy, even when the latter have more responsibility. The temporal structure of modern work creates another mismatch. The standard 40-hour work week, compressed into 5 8-hour days, is a relatively recent invention, a product of labor activism in the industrial era. Many people now work even longer hours. The rigid schedule, punching in and out at specific times, doesn't align with natural human rhythms of energy and motivation. Research on productivity shows that people can't sustain deep focus for 8 straight hours. Attention waxes and wanes. Yet work schedules rarely accommodate these natural rhythms, requiring constant presence even during periods of low energy. The separation of work from the rest of life is itself a historical anomaly. For most of human history, work, family, socializing, and leisure were integrated. You might gather food with friends, tell stories while making tools, have children playing nearby while you worked. The modern model segregates these domains. Work happens at the office during specific hours. Family and social life happen at home in the evenings and weekends. This separation can feel unnatural and contribute to work-life conflict, where the demands of work and personal life compete rather than complement each other. The disconnect between effort and reward in modern work also matters. In ancestral contexts, the relationship between work and outcome was clear. You hunted successfully, you ate meat. You gathered more berries, you had more food. Modern work involves multiple layers of abstraction. You perform tasks. Those tasks contribute to some larger process. That process generates revenue for the company. The company pays you a salary. You use that salary to buy goods. The chain of causation is long and opaque. This can undermine intrinsic motivation. Humans are motivated not just by external rewards, but also by the inherent satisfaction of accomplishment and mastery. When you can see the direct results of your work, when you build something tangible or help someone directly, there's an intrinsic reward. Much modern work lacks this. You might spend a day in meetings, send dozens of emails, update spreadsheets, and at the end of the day, struggle to articulate what you actually accomplished. This can lead to a sense of futility and meaninglessness. There are also issues around specialization. Modern economies depend on extreme specialization. People spend years training for very specific roles and then perform narrow tasks within those roles. This specialization increases efficiency, but it also means that individuals rarely engage with the full scope of productive activity. You might be very skilled at one small thing, but lack the broad competence that characterized ancestral humans, who needed to know how to do many things: find food, make tools, navigate terrain, build shelter, treat injuries. This narrow specialization can feel constraining and leave people feeling dependent and disconnected from the material world. There's a movement toward reclaiming skills like gardening, cooking, woodworking, crafts, activities that allow people to create tangible things with their hands. The popularity of maker spaces, DIY culture, and homesteading reflects a hunger for more direct, complete forms of productivity. So what might more human-aligned work look like? At the individual level, if you have the privilege of choice in your work, seek roles that align with your values and allow for autonomy, mastery, and purpose. Psychologist Dan Pink has argued that these three elements, autonomy, mastery, and purpose, are key to intrinsic motivation. Work that allows you to make decisions, develop skills, and contribute to something meaningful is far more satisfying than work that's purely instrumental. Try to incorporate movement into your workday. Take frequent breaks to stand, stretch, walk. Some people use standing desks, treadmill desks, or simply work in different locations throughout the day. Have walking meetings when possible. The goal is to break up long periods of sitting, create boundaries between work and personal life. With the rise of remote work and digital connectivity, the lines have blurred, and many people find themselves working at all hours. This is not sustainable. Establish clear times when you're off work and protect those times. Engage in activities outside of work that provide meaning, connection, and accomplishment. At the organizational level, employers can design work environments and structures that better align with human nature. This includes providing autonomy where possible, allowing workers to have input into how they do their tasks. It includes creating opportunities for movement and breaks, recognizing that sustained sitting is harmful. It includes fostering social connection among co-workers through collaborative projects, shared spaces, and team-building activities that feel genuine rather than forced. Some companies are experimenting with shorter work weeks, recognizing that productivity doesn't necessarily scale linearly with hours worked. Trials of 4-day work weeks have shown that workers can maintain or even increase productivity while working fewer hours, with significant improvements in well-being. Compensation structures also matter. When possible, providing workers with a clear connection between their efforts and outcomes can enhance motivation. Profit sharing, employee ownership, and transparent metrics help people see how their work contributes to larger goals. At the societal level, we might need to rethink some fundamental assumptions about work. The idea that everyone should work full-time in specialized roles, from their 20s to their 60s, with brief vacations in between, is not a law of nature. It's a social arrangement that serves certain economic functions but may not serve human flourishing. As automation and artificial intelligence transform the nature of work, we have an opportunity to reimagine what work could be, potentially creating more flexibility, more time for non-market activities like care work and community participation, more alignment with human needs and rhythms. The workplace mismatch reminds us that work is not just about economic production. It's also about identity, purpose, social connection, and using our capacities in fulfilling ways. When work is structured in ways that ignore our evolutionary heritage, it becomes a source of distress rather than satisfaction. But work doesn't have to be this way. By understanding the mismatch, we can begin to design work structures that are more humane, more aligned with who we are as biological and social beings. The sensory shift, nature deficit disorder. There's a concept that has gained traction in recent years, articulated by journalist Richard Louv in his book, Last Child in the Woods. He calls it nature deficit disorder, It's not a medical diagnosis, not recognized in the DSM or ICD, but it captures something real: the consequences of spending vastly less time in natural environments than humans have throughout most of our evolutionary history. Our ancestors lived in nature, not just in it, the way we might say someone lives in a city, but truly immersed in it. They woke to birdsong and sunlight, walked on soil and grass, climbed trees, swam in rivers, felt rain on their skin. They knew the cycles of the moon, the patterns of stars, the habits of animals. Their survival depended on this intimate knowledge of the natural world. The sights, sounds, smells, and textures of wilderness were the constant backdrop of existence. This immersion shaped human sensory systems. Our eyes evolved to perceive the full spectrum of natural light and to detect patterns in foliage, motion of animals, ripples in water. Our ears evolved to distinguish different natural sounds: the rustle that might indicate an approaching predator, the calls of birds signaling food or danger. Our sense of touch developed to assess textures of plants, animals, materials. Even our sense of smell, though diminished compared to many other mammals, retains sensitivity to natural scents that can convey information or evoke powerful emotional responses. Beyond the sensory, there's evidence that exposure to natural environments affects psychological well-being in deep ways. Evolutionary psychologist E.O. Wilson proposed the biophilia hypothesis, suggesting that humans have an innate tendency to seek connections with nature and other forms of life, a tendency shaped by our evolutionary history. Research in environmental psychology has documented what's called the restorative effect of nature, the finding that spending time in natural settings reduces stress, improves mood, enhances cognitive function, and promotes recovery from mental fatigue. The mechanisms behind these effects are still being explored, but they likely involve multiple pathways. Natural environments tend to be less cognitively demanding than urban environments. In a city, you're constantly processing stimuli, navigating traffic, responding to signs, avoiding obstacles, filtering out noise. This requires what psychologists call directed attention, the effortful focus on specific tasks. Natural environments, in contrast, engage what's called involuntary attention or fascination, the effortless interest captured by clouds, flowing water, rustling leaves, animal movements. This allows directed attention to rest and recover, reducing mental fatigue. Natural environments also tend to have fractal patterns, repeating patterns at different scales, found in coastlines, tree branches, clouds. Research suggests that humans find fractal patterns aesthetically pleasing and physiologically calming. Exposure to these patterns may reduce stress through their effects on visual processing. The sounds of nature, running water, birds, wind in trees, have different acoustic properties than urban sounds. They tend to be less abrupt, more predictable, and lack the jarring quality of mechanical noises. Studies show that natural sounds lower blood pressure and heart rate, while urban sounds do the opposite. Then there's the question of microbial exposure. The hygiene hypothesis in immunology suggests that exposure to diverse microorganisms, particularly early in life, is important for proper development of the immune system. Our ancestors lived in close contact with soil, water, animals, plants, all teeming with microbes. Modern urban environments are comparatively sterile. We spend most of our time indoors, where microbial diversity is low, and we use antimicrobial products that further reduce exposure. This lack of microbial contact may contribute to the rise in allergies, asthma, and autoimmune diseases in industrialized societies. Fast forward to the present. In many developed nations, people spend more than 90% of their time indoors. Children's outdoor play has declined dramatically. Where previous generations might have spent hours exploring woods, creeks, and fields, today's children often have tightly scheduled lives, filled with structured activities and screen time. Parents, concerned about safety, keep children under close supervision, limiting unstructured outdoor exploration. Adults fare little better. Work keeps most people indoors. Commutes are often in cars or trains, not walking through parks. Recreation increasingly centers on screens and indoor venues. Even in cities with green spaces, many people don't make time to visit them regularly. When they do, it's often for exercise rather than for simply being present in nature. The built environment has become less natural even in its aesthetic. Modern architecture often features stark, geometric forms, smooth surfaces, monochromatic color schemes, very different from the organic shapes, textures, and colors of natural environments. Urban landscapes are dominated by concrete, asphalt, steel, glass. While some cities have parks and trees, many neighborhoods, particularly lower income areas, are concrete jungles with minimal green space. This nature deficit has consequences. Studies show that people living in areas with less green space report lower life satisfaction, higher rates of mental health problems, and greater physiological stress markers. Children with limited nature contact show higher rates of ADHD symptoms, anxiety, and depression. Hospital patients who can see trees from their windows recover faster than those who can't. Conversely, interventions that increase nature contact show benefits. Green prescriptions, where doctors prescribe time in nature, have been adopted in some health systems. Shinrin-yoku, or forest bathing, a Japanese practice of mindful time in forests, has been shown to lower cortisol, improve mood, and enhance immune function. Even brief exposures to nature, a 5-minute walk in a park, looking at images of natural scenes, can have measurable positive effects. The nature deficit is particularly stark in its impact on children's development. Outdoor play in natural settings provides opportunities for physical development, gross motor skills, coordination, strength, and fine motor skills through manipulation of natural materials. It provides sensory richness, varied textures, smells, sounds, visual complexity that indoor environments rarely match. It encourages creativity and imagination as children invent games, build forts, explore. It teaches risk assessment as children navigate trees, water, uneven terrain. Perhaps most importantly, unstructured time in nature allows children to develop a sense of autonomy and competence. They can make decisions, solve problems, experience consequences in relatively low-stakes ways. This is crucial for developing confidence and resilience. The trend toward intensive parental supervision and elimination of unsupervised outdoor time may be contributing to the increases in anxiety and fragility observed in today's youth. The environmental crisis adds another dimension to this discussion. As humans have become more disconnected from nature, they've also become less concerned about its destruction. People who regularly spend time in natural environments tend to care more about conservation and environmental protection. They develop what's been called an ecological identity, a sense of connection and responsibility toward the natural world. In contrast, people who have little direct contact with nature may intellectually understand environmental problems, but lack the emotional connection that motivates action. This is troubling because we're in a period of unprecedented environmental change and destruction. Climate change, deforestation, species extinction, pollution, these are existential threats. Yet public response has been insufficient, in part because many people don't feel a visceral connection to what's being lost. They've never known wild nature intimately enough to mourn its absence. So what can be done about nature deficit? At the individual level, prioritize time outdoors. This doesn't require moving to the wilderness or taking exotic trips. Local parks, gardens, tree-lined streets, even potted plants indoors can provide some benefits. The key is regular, repeated exposure. Make it a practice to spend at least some time outside every day, even if it's just 15 minutes. Notice the sky, the weather, plants, birds, insects. Engage your senses deliberately. For families with children, prioritize outdoor play. Let children get dirty, climb trees, explore. Accept a degree of risk. Scrapes and bruises are part of childhood. Unstructured. Outdoor time is at least as valuable as structured activities. Create opportunities for children to develop a relationship with nature. Gardening, hiking, camping, visits to natural areas. At the community level, advocate for green space. This is an environmental justice issue. Lower-income neighborhoods often have less access to parks and trees, contributing to health disparities. Urban planning should prioritize creating and maintaining green spaces, planting trees, preserving natural areas. Schools should incorporate outdoor learning and recess in natural settings when possible. Some communities are adopting biophilic design principles, integrating natural elements into buildings and urban spaces. This includes green roofs, living walls, maximizing natural light, using natural materials, incorporating water features, and ensuring visual connections to nature from indoor spaces. These design choices can partially mitigate the nature deficit for people who must spend significant time indoors. At the personal level, bringing nature indoors can help. Houseplants improve air quality and provide a connection to living things. Natural materials, wood, stone, natural fibers, have different sensory qualities than synthetic materials. Views of nature from windows matter, as do images and sounds of nature, though these are less effective than direct contact. The ultimate solution, though, is cultural. We need to shift from seeing nature as something separate from human life, a nice amenity or a weekend escape, to seeing it as essential for health and well-being. We need to reclaim time outdoors as a priority rather than a luxury. We need to redesign communities to integrate green space. And we need to reconnect children with the natural world, giving them the opportunity to develop the same kind of intimate, embodied knowledge of nature that our ancestors had. The nature deficit is a relatively recent phenomenon, a byproduct of industrialization, urbanization, and the digital age. It's not inevitable. We can make different choices, both individually and collectively, to bring nature back into our lives. And given the evidence for nature's profound effects on physical and mental health, making those choices isn't just nice, it's necessary. Finding balance, practical solutions. We've explored numerous ways in which modern life creates mismatches with our evolutionary biology. Our diet, our physical activity, our sleep, our social connections, our mental health, our work, our disconnection from nature. The picture that emerges can feel overwhelming. Are we doomed to suffer as long as we live in modern civilization? Must we abandon technology and return to a hunter-gatherer existence to be healthy? The answer is no. The point of understanding evolutionary mismatch is not to reject modernity, but to navigate it more thoughtfully. We can't go back, nor should we want to. Modern life has brought immense benefits: longer lifespans, lower infant mortality, reduced physical hardship, technological marvels, expanded knowledge, greater individual freedom. The challenge is to retain these benefits while minimizing the costs imposed by mismatch. This requires a both-and approach rather than an either-or. We can embrace modern medicine while also prioritizing preventive health. We can use technology while also protecting time for face-to-face interaction. We can live in cities while also ensuring access to nature. The key is intentionality, making conscious choices rather than defaulting to whatever is easiest or most heavily promoted by commercial interests. At the individual level, this means taking responsibility for aligning your life more closely with your evolutionary needs. Let's summarize the practical strategies across the domains we've discussed. For diet, prioritize whole foods over processed ones. Shop the perimeter of the grocery store where fresh produce, meat, and dairy are typically located. Cook at home, when possible. giving you control over ingredients. Eat a wide variety of plants to ensure diverse nutrient intake. Minimize added sugars and refined carbohydrates. Pay attention to hunger and fullness cues, rather than eating mechanically. Make meals social occasions when possible, slowing down to enjoy food and company. Don't stress about perfection. The goal is progress, not purity. For physical activity, aim for movement throughout the day, not just isolated exercise sessions. Take breaks from sitting every hour. Choose active transportation, walking, biking, when feasible. Incorporate varied activities that engage different muscle groups and movement patterns. Strength training, cardiovascular exercise, flexibility work, balance exercises. Make movement social and purposeful when possible. Play sports with friends, go hiking, garden. Spend time outdoors in varied terrain. The specific activities matter less than consistency and variety. For sleep, establish a regular schedule, going to bed and waking at roughly the same times, even on weekends. Create a dark, cool sleeping environment. Get bright light exposure, ideally from the sun, in the morning and throughout the day. Dim lights in the evening and reduce screen time before bed. If you use screens at night, enable blue light filters. Consider establishing a screen-free wind-down period of 30 to 60 minutes before sleep. Avoid caffeine in the afternoon and evening. If you struggle with sleep persistently, consult a healthcare provider who specializes in sleep medicine. For social connection, prioritize face-to-face interaction. Schedule regular time with close friends and family. Limit time on social media, or use it primarily to facilitate in-person meetups, rather than as a substitute for them. Join groups or communities that meet regularly in person. Clubs, classes, religious congregations, volunteer organizations. Be present in conversations, putting phones away. Invest in relationships through active listening, showing up for others, being vulnerable. If you're feeling lonely, recognize that taking action to reach out, even when it feels hard, is essential. For mental health, develop practices that help regulate stress and emotion. This might include mindfulness meditation, which can be as simple as taking a few minutes each day to sit quietly and observe your breath. Engage in activities that provide flow, a state of absorbed focus, whether that's creative work, physical activity, or any pursuit that fully engages you. Limit consumption of distressing news and social media. Cultivate gratitude through practices like keeping a gratitude journal. Seek professional help if you're struggling with persistent symptoms of depression, anxiety, or other mental health concerns. There's no shame in therapy or medication when needed. For work, if you have any control over your work situation, seek roles that provide autonomy, opportunities for mastery, and a sense of purpose. Within your current job, look for ways to incorporate more movement, regular breaks, and physical activity. Set clear boundaries between work and personal time. Engage in activities outside of work that provide meaning and accomplishment. If your work is fundamentally misaligned with your values or chronically making you miserable, consider whether a change is possible, recognizing that this is a privilege not everyone has, but is sometimes necessary for well-being. For nature connection, make time outdoors a regular practice. Even brief daily exposures, a short walk, time in a garden, are valuable. Seek out natural areas in your community. Plan outdoor activities, hikes, beach visits, time in parks. Bring nature indoors with plants, natural materials, and views of greenery. For parents, prioritize outdoor play for children, allowing unstructured time to explore. Across all these domains, a few themes emerge. First, small changes add up. You don't need to overhaul your entire life overnight. Start with one or two areas where you feel mismatch most acutely. Make modest adjustments. Build habits gradually. Even incremental shifts toward more evolutionary alignment can yield benefits. Second, social support matters enormously. Changes are easier to sustain when you have companions. Find friends or family members who share your goals. Join communities of people working on similar challenges. Share your intentions with others and ask for support. Humans are social creatures, and we're more successful at behavior change when we're not alone. Third, environment matters more than willpower. Rather than relying on constant self-control, restructure your environment to make healthy choices easier. Keep processed foods out of your house so you're not constantly resisting temptation. Set up your living space to encourage movement. Keep exercise equipment visible. Remove chairs from certain areas to encourage standing. Configure your devices to minimize distractions. Design your social and physical environment to support the life you want to live. Fourth, self-compassion is essential. You will have setbacks. You'll eat junk food, skip workouts, stay up too late scrolling, feel lonely and anxious. This is part of being human, especially in a world that makes these failures easy. Rather than berating yourself, recognize that you're navigating a difficult environment. Learn from the experience and recommit to your intentions. Perfectionism is counterproductive and will only add to your stress. Finally, remember that individual solutions, while important, are not sufficient. Many of the mismatches we've discussed are products of systems and structures beyond individual control. Food deserts limit access to healthy food. Car-dependent urban design makes walking dangerous. Job insecurity creates chronic stress. Screen-based entertainment saturates culture. Addressing these requires collective action. The bigger picture, society and policy. While individual choices matter, they exist within larger contexts that either support or undermine those choices. A person trying to eat healthily in a food desert, where fresh produce is unavailable, faces obstacles that willpower alone can't overcome. A family trying to prioritize outdoor time in a neighborhood without safe parks or green space is constrained by their environment. A worker trying to reduce stress while facing job insecurity and punishing hours is fighting against structural realities. This means that fully addressing evolutionary mismatch requires changes not just at the individual level, but at the societal and policy levels. We need to examine how our collective structures, our food systems, our built environments, our workplaces, our educational institutions, our healthcare systems either exacerbate or mitigate mismatch. And where they exacerbate it, we need to advocate for change. Consider food policy. The modern food environment didn't arise by accident. It's the product of specific policy choices. Agricultural subsidies that favor commodity crops like corn and soybeans over fruits and vegetables, making processed foods artificially cheap. Marketing regulations that allow junk food companies to target children with sophisticated advertising. Food assistance programs that provide insufficient support for purchasing fresh, healthy foods. Zoning laws that limit where grocery stores can locate, contributing to food deserts. And lobbying by the food industry that has successfully blocked policies like soda taxes and clearer nutritional labeling. Changing this system requires political will and public pressure. It means supporting policies that make healthy food more accessible and affordable, subsidizing fruits and vegetables, restricting junk food marketing to children, ensuring that food assistance programs adequately cover the cost of nutritious food, and investing in infrastructure to bring grocery stores to underserved communities. It also means reforming school lunch programs to prioritize whole foods over processed products, and implementing nutrition education that teaches not just what to eat, but how to cook and prepare food. Urban planning and the built environment present another area where policy can address evolutionary mismatch. Our cities and suburbs have been designed primarily around automobiles, making walking and cycling difficult or dangerous in many places. This design choice has profound health implications, contributing to physical inactivity, social isolation, air pollution, and traffic deaths. Yet alternative models exist. Cities like Copenhagen and Amsterdam have invested heavily in cycling infrastructure, creating networks of protected bike lanes, that make cycling safe and convenient for people of all ages. These cities have high rates of active transportation and correspondingly better health outcomes. Walkable neighborhood design, sometimes called new urbanism, creates mixed-use communities where homes, shops, schools, and workplaces are in close proximity, allowing people to accomplish daily tasks on foot. These neighborhoods foster more social interaction as people encounter neighbors and develop local relationships. They provide better access to nature when green space is integrated into the design. And they support physical activity as a natural byproduct of daily life, rather than requiring special trips to gyms. Implementing this kind of design requires zoning reforms to allow mixed-use development, investment in pedestrian and cycling infrastructure, prioritization of public transit, and protection of parks and green spaces. It also requires resisting the pressure from developers and businesses that prefer car-dependent sprawl, which can be more profitable in the short term, even if it's less healthy and sustainable in the long term. Workplace policy is another critical area. The standard model of full-time employment, with rigid hours and limited flexibility, evolved during the industrial era and doesn't necessarily fit the needs of modern workers or the nature of contemporary work. Some countries and companies are experimenting with alternatives. The 4-day workweek, shorter total hours but the same pay, has been tried in various settings with positive results for both worker well-being and productivity. Flexible work arrangements, allowing people to adjust their hours or work locations, can help people align work with their natural rhythms and family obligations. Paid family leave, standard in most developed countries but still lacking in the United States, allows parents to care for infants without the impossible choice between income and bonding. Vacation time, also more generous in most developed nations than in the US, provides opportunities for rest, travel, and the pursuit of non-work activities that contribute to well-being. Workplace design that incorporates standing desks, walking paths, natural light, and green space can partially mitigate the health harms of sedentary work. These changes require legislative action, labor organization, and cultural shifts that value worker well-being alongside productivity. The resistance comes from a business culture that often prioritizes short-term profits and treats workers as interchangeable units of labor rather than as whole persons with complex needs. Education policy deeply affects children's health and development. The current model in many places emphasizes academic achievement measured by standardized tests, leading to reduced time for physical education, recess, arts, and unstructured play. Children spend increasing hours sitting at desks, often starting at very young ages, despite evidence that young children learn best through active, hands-on exploration. School days start early, particularly for adolescents, conflicting with their biological sleep patterns. An evolutionary perspective suggests different priorities. Schools should ensure substantial time for physical activity throughout the day, not just a single PE class or brief recess. They should incorporate outdoor education and nature contact. They should allow for movement during academic instruction, recognizing that children, especially young ones, aren't designed to sit still for hours. They should start later for adolescents, aligning with their shifted circadian rhythms. And they should prioritize social-emotional learning, teaching children how to form relationships, manage emotions, and navigate conflicts, skills that are as important as academic knowledge. Implementing these changes requires overcoming resistance from parents and administrators focused narrowly on test scores, as well as constraints from standardized testing regimes mandated by state and federal policies. But the evidence is clear. Children learn better when their physical and emotional needs are met, and schools that prioritize well-being alongside academics see improved outcomes on both fronts. Healthcare policy could also be restructured to address evolutionary mismatch more directly. Current systems in most countries are primarily reactive, waiting for people to get sick and then treating symptoms. This is necessary and valuable, but it's also expensive and often comes too late to prevent chronic disease. A system oriented toward preventing mismatch-related illness would prioritize different interventions. This might include covering lifestyle medicine, consultations with professionals who help people modify diet, physical activity, sleep, stress management, and other behavioral factors that drive chronic disease. It might include social prescribing, where doctors prescribe activities like nature walks, exercise classes, or community groups, rather than only medications. It might include covering gym memberships, healthy food, or stress reduction programs. Some health systems are beginning to experiment with these approaches, recognizing that paying for prevention is cheaper than paying for treatment of advanced disease. Mental health care deserves particular attention. Most countries dramatically underfund mental health services despite the enormous burden of psychiatric illness. Access to therapy is limited, with long wait times and high costs. Prevention efforts are minimal. An adequate mental health system would ensure accessible, affordable therapy for anyone who needs it. It would integrate mental health screening into routine medical care. It would fund mental health education in schools. And it would address the social determinants of mental health. Poverty, housing insecurity, discrimination, all of which create chronic stress that drives psychological distress. Technology regulation is another frontier for addressing evolutionary mismatch. Social media platforms, video games, and other digital products are engineered to be addictive, using sophisticated algorithms and design features to maximize engagement. This is particularly concerning for children and adolescents whose brains are still developing and who are especially vulnerable to these manipulations. Some countries are beginning to regulate tech companies more aggressively, limiting targeted advertising to children, requiring transparent algorithms, mandating features that help users track and limit their screen time. There's also growing discussion about age restrictions for social media. Some researchers and advocates argue that children under a certain age, perhaps 13 or 16, should not have access to social media platforms, given the documented harms to mental health and development. Others argue for better education about digital literacy and healthier use rather than outright bans. Either way, it's clear that the current situation, where tech companies profit from engaging children and teenagers in ways that may harm them, is untenable and requires regulatory intervention. Environmental policy connects to evolutionary mismatch in multiple ways. Climate change, pollution, and environmental degradation directly affect health, but they also represent a mismatch at the civilizational level. Human economic systems evolved over centuries to extract and consume resources without regard for long-term sustainability. Because for most of history, the environmental impacts were local and recoverable. Now we face global, potentially irreversible consequences. The mismatch is between short-term thinking and planning horizons of years or decades, and the much longer timescales on which environmental systems operate. Addressing this requires transitioning to sustainable practices, renewable energy, circular economy models that minimize waste, protection of ecosystems and biodiversity. It also requires reconnecting people with nature so they develop the ecological identity that motivates environmental stewardship. As we discussed earlier, people who spend time in nature care more about its protection. Policies that create and maintain green spaces, support environmental education, and ensure that all communities have access to nature serve both individual well-being and collective environmental goals. These policy changes won't happen automatically. They require political organizing, advocacy, voting for candidates who prioritize health and sustainability, supporting organizations working on these issues, and sometimes direct action. It requires overcoming powerful interests that benefit from the status quo, food companies that profit from processed products, car manufacturers and oil companies that profit from automobile dependence, tech companies that profit from engagement regardless of harm, employers that profit from exploiting workers. The good news is that there's growing recognition of these problems and increasing momentum for change. Public health advocates, environmental organizations, labor unions, and concerned citizens are pushing for policies that address evolutionary mismatch, even if they don't always use that term. And there are examples of successful reforms: soda taxes that have reduced consumption of sugary drinks, smoke-free laws that have reduced tobacco use, urban design improvements that have increased active transportation. Change is possible, but it requires sustained effort. Individual actions, while important, need to be coupled with collective action to create environments that make healthy, fulfilling lives easier rather than harder. The evolutionary mismatch framework provides both a diagnosis of many contemporary problems and a roadmap for solutions at multiple levels, from personal choices to policy reforms. Conclusion: living with mismatch. We've traveled a long road together through the landscape of evolutionary mismatch, examining how our ancient biology interacts, often uncomfortably, with our modern world. We've seen how our preferences for sweet and fatty foods, shaped by scarcity, lead to overconsumption in an environment of abundance. How our bodies designed for movement deteriorate when we sit for hours each day. How our sleep patterns, synchronized for millennia with the natural cycles of light and dark, are disrupted by artificial lighting and glowing screens. How our need for close social bonds goes unfulfilled in a world of digital connections and social fragmentation. How our minds, evolved for small group living and immediate challenges, struggle with chronic stress, information overload, and existential uncertainty. How our work has become divorced from purpose and physical engagement. And how our disconnection from nature leaves us depleted and disoriented. The picture that emerges is humbling. For all our technological prowess, for all our scientific knowledge, for all our medical advances, we haven't escaped the constraints of our biology. We remain, at our core, animals shaped by evolutionary forces, carrying within us genetic instructions written over hundreds of thousands of years. And when we create environments that diverge too dramatically from those that shaped us, we suffer consequences. But recognizing this doesn't require despair or resignation. Quite the opposite. Understanding evolutionary mismatch empowers us to make different choices, both individually and collectively. It explains why certain health problems have become epidemic, despite our best efforts to address them through conventional means. It reveals that many of our struggles aren't personal failings, but natural responses to unnatural environments. And it points towards solutions grounded in aligning our lives more closely with our biology. The path forward isn't about rejecting modernity or attempting to recreate ancestral conditions. That's neither possible nor desirable. We can't and shouldn't abandon antibiotics, vaccines, electricity, computers, or the countless other innovations that have genuinely improved human life. The question is how we can thoughtfully integrate these benefits while minimizing the costs of mismatch. How we can be modern without being miserable. How we can embrace progress while preserving health. This requires a fundamental shift in perspective. For the past few centuries, the dominant cultural narrative in industrialized societies has been one of transcendence. The idea that humans can and should transcend natural limitations through technology and reason. We've imagined ourselves as separate from nature, capable of reshaping the world to our will without consequence. And in many ways, we've succeeded spectacularly. We've extended lifespans, reduced infant mortality, eliminated certain diseases, created unprecedented material abundance, connected people across vast distances. But we've also created new problems, and many of them stem from forgetting that we are biological beings embedded in nature, not separate from it. The evolutionary mismatch framework reminds us of our embodied, evolved nature. It asks us to work with our biology rather than against it, to acknowledge our needs and limitations rather than denying them, to design environments that support flourishing rather than merely tolerating our presence. On an individual level, this means taking responsibility for choices within your control. It means being intentional about diet, movement, sleep, social connection, time in nature, work-life balance, and screen time. It means recognizing that convenience and novelty aren't always synonymous with well-being. It means sometimes choosing the harder path, cooking instead of ordering takeout, walking instead of driving, having a conversation instead of scrolling, going to bed instead of watching another episode, because you understand that these choices serve your deeper needs. It also means cultivating self-awareness and self-compassion. You'll navigate these tensions imperfectly. You'll make choices you regret. You'll fall into patterns that don't serve you. This is inevitable when living in an environment that constantly pushes against your evolutionary needs. The key is to notice, learn, and adjust rather than spiral into shame or giving up entirely. On a collective level, addressing evolutionary mismatch requires redesigning systems and institutions. It requires food systems that prioritize nutrition over profit, built environments that support active transportation and access to nature, workplaces that respect human needs for autonomy and rest, educational institutions that honor children's developmental needs, healthcare systems that emphasize prevention and holistic well-being, technology platforms that prioritize user welfare over engagement, and policies that protect the natural environment that sustains all life. These changes won't happen spontaneously. They require advocacy, organizing, political action, and sometimes direct resistance to powerful interests that benefit from the status quo. But they're possible. History shows that determined groups of people can reshape institutions, shift cultural norms, and create change that once seemed impossible. The abolition of slavery, women's suffrage, the civil rights movement, environmental protection, workplace safety standards, all emerged from organized efforts by people who recognized injustice and demanded better. The evolutionary mismatch framework also invites humility about the limits of technology as a solution to human problems. For every problem that technology solves, it often creates new ones. Agricultural technology solved immediate hunger but created chronic diseases of affluence. Transportation technology provided mobility but led to sedentary lifestyles. Communication technology connected us across distances but fragmented our attention and undermined face-to-face intimacy. This doesn't mean technology is bad. It means we need to be thoughtful about how we develop and deploy it, anticipating unintended consequences and being willing to adjust course when harms emerge. There's also a broader philosophical dimension to this discussion. Evolutionary mismatch raises questions about what we value and what kind of world we want to create. Do we value efficiency and economic growth above all else, even when they come at the cost of human health and environmental sustainability? Or do we value flourishing, meaning time for rest, connection, beauty, engagement with the physical world? Do we see humans primarily as economic units, workers and consumers whose worth is measured by productivity? Or do we see humans as complex beings with physical, social, emotional, and spiritual needs that deserve to be honored? The economist E.F. Schumacher wrote in his book, Small is Beautiful, that the system of nature, of which man is a part, tends to be self-balancing, self-adjusting, self-cleansing. Not so with technology. This insight from decades ago remains relevant. Our technologies, our economic systems, our social structures don't automatically balance themselves or correct course when they create problems. That requires conscious human intervention, guided by values and understanding of human nature. The evolutionary perspective offers one source of guidance, suggesting that systems and practices aligned with human evolutionary heritage are more likely to support flourishing than those that dramatically conflict with it. This doesn't mean evolutionary history determines what's right or good, what's called the naturalistic fallacy, the error of assuming that what's natural is automatically moral or desirable. Nature is often brutal and amoral, but it does mean that working against fundamental biological needs, tends to create friction and suffering, while working with them tends to feel easier and more sustainable. As we look to the future, the challenges of evolutionary mismatch may intensify. Technology continues to advance at an accelerating pace. Artificial intelligence, genetic engineering, brain-computer interfaces, virtual reality, all promise to further transform human life in ways we can barely imagine. Some of these technologies might help address current mismatches. Perhaps we could use AI to design healthier food systems or urban environments, or use genetic therapies to treat diseases that arise from mismatch. But they also risk creating new mismatches, deepening our disconnection from physical reality, from our bodies, from each other, from nature. Navigating this future wisely will require keeping evolutionary insights in mind, even as we develop new capabilities. It will require asking not just, can we do this, but should we? And what will the consequences be for human flourishing? It will require putting human needs at the center of design, rather than treating them as afterthoughts or obstacles to overcome. There's something profound and perhaps even hopeful in recognizing that many of our modern struggles stem not from defects within us, but from misalignment between our nature and our environment. It means that solutions exist. It means that we're not broken. We're just living in conditions for which we weren't designed. And while we can't change our fundamental biology quickly, we can change our conditions. We can create lives and societies that honor our evolutionary heritage while embracing the genuine benefits of modernity. This is the challenge before us, to live as modern humans, benefiting from scientific knowledge and technological tools, while remaining grounded in the biological realities that make us human. To build a world that's both progressive and sustainable, both innovative and life-affirming. To recognize that we are animals, shaped by millions of years of evolution, and to celebrate rather than deny that fact. To reclaim the wisdom of our bodies, the rhythms of nature, the importance of community, the value of simplicity and presence, even as we navigate the complexity of contemporary life. The story of evolutionary mismatch isn't a tragedy, though it contains tragic elements. It's better understood as a recognition, an awakening to the true nature of many problems we face, and to the possibility of addressing them through understanding and intentionality. Every time you choose to cook a whole food meal, take a walk, get enough sleep, connect face-to-face with someone you care about, spend time in nature, or resist the pull of your phone, you're acknowledging your evolutionary heritage and choosing alignment over mismatch. Every time communities invest in green space, walkable design, healthy food access, or mental health support, they're creating conditions that make flourishing easier. We stand at a unique moment in human history. We have unprecedented knowledge about our evolutionary past and our biological needs. We have tools and resources that our ancestors couldn't have imagined. We also have urgent challenges, public health crises, environmental degradation, social fragmentation that demand new thinking and new approaches. The evolutionary mismatch framework doesn't provide simple answers to these complex problems, but it offers a valuable lens, a way of seeing that can guide both individual choices and collective action. Ultimately, the goal isn't perfection, it's progress. It's moving in the direction of greater alignment, greater flourishing, greater sustainability. It's recognizing that we're part of nature, not separate from it, and that our well-being depends on honoring that connection. It's building lives that feel good not just in the moment, but over time, that support not just our individual success, but the well-being of our communities and the health of the planet that sustains us all. This is possible. It requires work, attention, courage to make different choices than those that society defaults to or that marketing encourages. But it's possible, and increasingly, it's necessary. The costs of evolutionary mismatch in chronic disease, mental illness, environmental destruction are mounting. We can no longer afford to ignore the gap between our ancient biology and our modern world. So this is both a diagnosis and an invitation. A diagnosis of why so much feels hard, why so many are struggling despite material abundance, why our modern world produces so much distress alongside its comforts, and an invitation to do things differently, to reclaim aspects of our evolutionary heritage, to redesign our environments and institutions, to live more intentionally and more fully. The work begins where you are, with your next meal, your next movement, your next moment of connection, your next choice about how to spend your precious time and attention. It expands outward to your family, your community, your voice in the public square. It's both deeply personal and unavoidably political, and it matters for your own flourishing, for the well-being of those you love, for the kind of world we'll pass to future generations. We are the inheritors of an extraordinary evolutionary legacy, shaped by millions of years of adaptation to life on this planet. We're also the creators of an unprecedented moment, unique in human history for its technological sophistication and its global challenges. Holding both of these truths together, honoring our past while building our future, acknowledging our limits while reaching for our potential, this is the balancing act we must perform. The evolutionary mismatch framework gives us tools for that performance, helping us understand where we've come from so we can better navigate where we're going. The ancient and the modern, the biological and the technological, the individual and the collective, these aren't opposing forces that require choosing sides. They're dimensions of human existence that must be integrated, harmonized, held in creative tension. That integration won't look the same for everyone. Different people will find different balances, different ways of honoring their evolutionary needs while engaging with contemporary possibilities. But the underlying principle remains. We flourish when we live in alignment with our nature, and we struggle when we don't. Understanding this gives us a compass, not a rigid map, a direction if not a destination. As we close this exploration of evolutionary mismatch, the invitation stands. Look at your life through this lens. Notice where you feel the friction, where modern demands chafe against ancient needs. And then, with compassion and creativity, experiment with changes that bring you into greater alignment. Start small, build gradually. Be patient with yourself and with the process. The mismatch is developed over decades and centuries. They won't be resolved overnight. But every step toward alignment matters. Every choice to honor your body's need for movement, for whole food, for darkness and rest. Every moment of genuine connection with another human being. Every hour spent in nature. Every boundary you set to protect your attention and your energy. These aren't luxuries or self-indulgences. They're acts of reclaiming your humanity, of living according to your deepest nature, rather than in constant conflict with it. And if enough of us make these choices, if we collectively decide that flourishing matters more than convenience, that health matters more than profit, that sustainability matters more than short-term growth, then we can begin to shift not just individual lives, but entire systems. We can build a world that works with human nature rather than against it. A world that honors our evolutionary past while embracing our technological future. A world where the gifts of modernity support rather than undermine our well-being. That world is possible. The path toward it begins with understanding, and understanding begins with recognizing the profound gap between the environments that shaped us and the environments we now inhabit. This is the story of evolutionary mismatch, and while it explains much about our struggles, it also illuminates our possibilities. May we have the wisdom to learn from it, the courage to act on what we learn, and the perseverance to keep moving toward lives and societies that allow all people to thrive in the fullest sense. The ancient wisdom is still within us, coded in our genes, present in our body's deep knowing of what they need. The modern world surrounds us, full of marvels and challenges in equal measure. Our task is to bridge these worlds, to live as whole human beings in this extraordinary moment. It's difficult work, necessary work, sacred work, and it's work we must do together, if we hope to flourish rather than merely survive in the world we've created.